Thank you, Raphael. Yeah, let's talk about Django validators, which are pretty cool. And we're going to see how validators just sort of like let us build more powerful and complex models. And I'm going to go ahead and set up a new Django project that we're going to use to kind of get things going. And we're just sort of going to create a very, like, the world's simplest Twitter. And I'm going to go to my code directory where I keep my projects. I'm going to make a new directory. And move into my new directory. And I'm going to, I think I'll wait a minute to open that up. And I already have Django installed. Oh, I apologize. I jumped ahead a bit. I need to create a new Python environment for our project. And what I've been doing is in my home directory, which is this ~/ I have a directory called venv. And I think, Raphael, we had talked about this at one point, and I know some other folks might be doing this. And it's sort of a toy Twitter, so I'm going to call it Twitter project. And just go ahead and create a new Python environment. I apologize, I'm jumping around a little bit here. I just want to confirm that my new Python environment exists. And now I'm going to go navigate back to the directory where I want to create my Django project. And I'm going to go ahead and activate the virtual environment that we just created. Again, that ~/ is my home directory. And on the command line, I've got my command prompt telling me that I'm in that environment. And now in this environment, we can go ahead and install Django. And now we've got Django installed in our environment, and it's properly scoped and everything. And I'm just going to clear a little space. And we've got a little bit of nesting going on here. And now that I have a Django project going, I want to open it up in VS Code. So that I can have my Explorer terminal open with everything. And let's just open it up there just for the heck of it. And note that because I started up my last terminal closed, I'm no longer in my Python virtual environment, so I have to start that up again. What I've been doing that I kind of like is I'll put my terminal up here in a tab because it lets me move around pretty easily. And now we're kind of cooking. Now we're going. And on the command line, I can create a new database. The way I've installed PostgreSQL gives me this nice create DB command. And we're just going to call it Twitter. And I was going through some of this yesterday, so that database already exists. And I would recommend just, I wouldn't worry too much about like typing code along for this one, unless you know that that's the way you learn best. I would say just watch. And we're also gonna go ahead and install a package called psychopg2. And Raphael, I'm not sure if that's the correct Django pronunciation.
That's how I say it.
PG2. I started to say something else and I was like, wait, that's not how Raphael says it. Let's see here. Could not find a version that satisfies requirements PG2.
Oh, it's a typo.
Oh, thank you. Where's the typo?
I think it's PS1.
Oh yeah, thank you so much. Awesome. Yeah, and this second warning about the version of pip I'm using, we can just ignore. Thank you very much. I appreciate it. And PsychoPG2, as we may have talked about a bit, is our ORM2O object relation management tool. And that's what lets us create these models that Django uses that interact with our database and just let us do all sorts of good stuff. And then I also have to go in to settings PY, and which is the settings file for our Django project, and tell it that we want to use Postgres as our database and not the default value of this other kind of relational database called SQLite. And give it the name of our database, which is just Twitter. We're not using like the path that we're on or anything like that for the name. And so that should be most of it. And then we should be set up and we should be able to start building things. So we do want to create a Django app for some good project structure. So I'm going to go ahead and do that now. And we have to do a little more setup here. And as you folks are probably noticing, I like to use the find functionality a lot. I think it's just an easy way to get around. And now we're going, and now we can start creating some models. And we're going to do that inside our Twitter app of our Django project. And let's just start by creating a user model. And giving our user a couple properties. And can someone just maybe walk through what's going on with this char field property here?
You're just setting a max length for that variable. It's similar to in a database when you're defining the class and the size of the data object.
Yeah,
So
exactly.
it's a string with 255 characters.
Yeah. And like something that I've gotten in the habit of doing is I develop that I like a lot is I'll just like open tabs on stuff as I go, kind of like we saw earlier in the day with what was it? Oh, with the post dictionary like object. Like I've just found it useful over the years to kind of always glance at the documentation for like the different things that I'm using. So like as I go, I'll start kind of like opening up tabs on stuff, especially as I'm relatively new to Django. So this is kind of part of like my learning process of how I do that. And thank you, Justin. And we should probably also create an email field. And this one can be a bit shorter. So it's not a huge deal. And here, like, you know, I'm relatively new to Django. I'm not sure what email field is, and I want to check it out. And this is great. It tells me that email field is a char field. So we're using something that we know under the hood, and that it uses a validator called email validator. And I don't need to know everything that email validator does, but I want to just glance it over just to get like the big picture. And see if there's anything that might be a gotcha or like a warning or something that I need to know. And there's nothing really crazy here. You know, most email validators use regex in some form. We can also create, they call it an allow list, a whitelist of allowed email addresses if we wanted to. But we're not going to worry about that now. And we get a nice default error message that says enter a valid email address if we try to enter an invalid one. And we kind of know all we need to know for the moment, and we can move on. And our user should have an age. And that age is going to be an integer. And our user should have an account type. And there are a lot of different ways to implement an account type. Like another approach would have been to do is paid account and have that be a Boolean field. That gives us a little less flexibility. The truth is that setting this max length of 4 doesn't give us a lot of flexibility either. But we're going to come back to this later and build on this a bit more. And it's good for learning too. And the truth is that as time goes on, if we add a new account type like I don't know, promotional, we would just change the max length and we might then make a database migration. So we've got our model. It directly correlates to a user table in the database. And we've added some basic validation. Email field really is the most complex like validation that we have, in that it's using an email validator. Let's go ahead, and we have to actually now build this table in our database because we've created the model, but we haven't run a migration or anything like that. So let's go ahead and do that. And as we've seen, this creates a migration file. We can take a look at it. We can kind of see what's going on. It's using our model, and it's going to then generate SQL that gets executed in our database, which creates this user table for us. And if we want to, we can, whoa, sorry. The keyboard shortcut of one thing is fighting with the keyboard shortcut of another thing. Let me see if I can quickly get rid of this. If not, I'm just not going to worry about it. There we go. There we go. Yeah, and that's what I want. So I was looking around at this the other day. We were talking a bit about how it'd be nice to see the SQL that our migration files generate. And Django does give us a command called SQL migrate that will do that. And what we have to pass it is the name of the app that we're interested in, the Django app, and then the number of the migration file. It's a little confusing. We don't pass it the full file name. And then this is the actual SQL that is created and that Django will execute inside our database when we run the migration. And let's go ahead and do that now. And I probably, because I was doing this yesterday, that step is already done in the database. And let's go ahead and just log in. I can see, so I just logged into the Postgres command line tool. /L gives me the list of databases. I can connect to the Twitter database. And now that I'm in there, I can see the list of tables. And there's a ton, but we have Twitter app user. And that's the one that we care about that we just created. And we can see what that looks like too. And we see that we have pretty much what we expected. We have first name, last name, email, ID we get for free. Django does that for us. And I believe that's our primary key. Though I'd have to double check to confirm that. And then I think the really thing of interest here is, so email, as we said, it's in our model, it's an email field. As we saw from looking at the Django docs briefly under the hood, that's a char field. And here in the model code, when we're creating new models, some additional validation will be applied. But from the perspective of the database, it's just another column, a character column, a varchar column with a limit of 100 characters. So that's kind of just getting the ball rolling. And now we're going to start building some custom validators of our own. And before doing that, I just want to check in with folks and see if anyone has any questions or anything like that, or anything that'd be good for me to quickly review.
Yeah, do you have like a notes file by any chance right now?
Yeah, Dalton, thank you so much for saying that. I don't, and I should. So let me go ahead and do that.
Could you just throw in that it was like the 001 migrate or whatever code that actually shows you the SQL or SQL?
Oh yeah, that command.
Yep. Thank you.
Yeah, for sure. I'll flesh that out a bit, but yeah, good call, Dalton. Thank you. I am used to Vim there. I was getting a little lost with my saving. Let's see, we can close that out. Got that. Let's put notes maybe last. And I think that's what we want. Cool. Yeah. Thank you, Dalton. Let's go ahead and let's build our own validator. And maybe let's do it for the age property on our user model, because for all sorts of legal reasons, we need to make sure that users of Twitter are at least 13 years old. And a validator is just a function. So let's create a function called validate age. And basically, we don't want users who are less than 13 to be able to join. So we need to throw an error. We're gonna import a couple modules here to help us. We're gonna import a validation error module. And now we've got our validator written, and that's pretty much all we need. And the way to use it, Django makes it really straightforward. There is a validator's argument that we can pass to all these different fields. And it takes a list of validators. And that's all we need to do to have this validate age function working and being applied as a validator. And again, this is all happening in the Django code. It all happens before any sort of SQL query is made. So this doesn't affect our migration. And in fact, we should be able to, like if I look at that migration, it's pretty much the same. It should be exactly the same. In fact, we have this age integer that's the same. And if we run our migration again, we're told there's no migrations to apply. Have changes that are not yet reflected in a migration. Yeah, we can make migration. I don't think it's going to change anything, but we can, let's see. Actually, that will be good to check. Alter field age. So I guess I wasn't quite right because the migration does have a lot of Python code. It is Python code. So we do have our age validator in here.
That actually kind of surprises me. I wouldn't think that you would need to run a migration just to add a validator.
Yeah, it's an interesting question too. Like I would imagine the validation code gets called well before the validation. I'm very curious to see what the SQL is for our new migration. My suspicion is that nothing gets changed in the database, but I'm not sure. So this is interesting because the SQL says that we're going to alter this field, but it doesn't really show what the alteration is. So let's run it and see what happens. And if I go to the database here, and look at it, the age property is exactly the same. It's still an integer. So maybe Python, sorry, not Python, maybe Django does some housekeeping that way. So our validations are reflected in the models for migrations, but not necessarily in the SQL. And that's probably for, maybe there are certain cases where we might make a modification or add a validator that does touch the SQL. I think that's unlikely, but maybe something like that occurs. Let's add a little bit more to this validation function to make it a little fancier. We haven't talked a lot about this. I'll use that in a moment. What we want to do is just add an F string. And make our error message a little nicer. And tell the user what the problem is too. That's the real, that's a value here that the user gets that input back. And then just to kind of give you folks a preview and show you an example of as our programs get more sophisticated, what this text method does is it's building up like a list of constant string messages that we use. And as you can tell from the name of this library or this module translation, this matters when we're working in different languages. So this is a tool that we would use down the line if when we need to, it's called like internationalizing our Django app so that users from different countries, different languages can use it and the error messages are in the correct language. There are also a lot of built-in validators in Django that we can use. And let me show you folks those right now. And we're just going to import them all for the sake of simplicity. And it comes from the django.core.validators library. And they have one called min value validator. So let me. Let me do a little cleanup here to make this code a little more readable. And VS Code is giving me this great autocomplete. And I forgot that I have to add the validator's argument. It's a named argument and it takes a list. So I still have to pass it in. And this is another way of doing the same thing. And kind of like I was saying, when I'm learning like a new framework or something, I like to just kind of keep Googling as I go and just glance at stuff. And this is helpful because this tells me what happens in the error case here. It's raising a validation error. It has a code. So it's an error message with a little bit of data, basically. In terms of the pros and cons for this specific situation of these two approaches, Raphael, I'm curious what you think. I actually, especially as someone new to the framework, I sort of prefer just writing my own validation functions because I know exactly what it does. To me, this min value validator, this is really useful. Like if you're working on a big Django project or you've just been working with Django for a long time and you're familiar with everything. For me, as someone newer to Django, it adds just kind of another level of complexity. While with this function, I can see exactly what my code does, and I can also write a nicer error message. Is that kind of your take on things as well, Raphael, or would you recommend kind of using the built-in validation functions as much as possible?
So in this case, I would agree with you, just because like minimum value is such a simple constraint. Just the number needs to be larger than some other number. I feel like using Django's version of this just makes things a little bit more complicated because the code is somewhere else. You have to actually know how the Django built-in version works and confirm that it's just as simple as you think it is. Whereas if you write your own validator and it's just like one line of code, you can just look at it and you know exactly what it does. You don't have to worry about learning the built-in behavior. But for some other validators that are more complicated, I would probably use the built-in validator instead of rewriting it myself. So like the email validator is maybe a good example. It's honestly like awkwardly complicated to determine if something is or is not an email address. There are a lot more rules than you might expect. And there can be like specific email addresses that defy your expectations about what an email address can or cannot look like. So I would prefer to use the built-in validator just to avoid, writing that logic myself. Similar to like a birth date validator or a social security number validator. There are some exceptions to the rules of like how you validate those things that might surprise you. So I would just use like a pre-existing validator instead of writing my own.
Yeah, that's great advice. And I want to echo everything that you're saying. And you're totally right, especially for email and things like birthdays and social security numbers. And that's kind of a lot of the value of Django too, is that it's done that work for us. And we have like an agreed upon community standard of like, this is what an email should be. This is not, like, this is what a social security number should be. This is not. And most of the time that's going to be correct for whatever we're doing. Yeah, thank you, Raphael. And I just want to check in and see what questions or thoughts folks have. Everyone feeling good? Daniel, yes, sir.
What happens if you add like I don't know, that same validator in a char field? Like, can you do like a min value on a string? Like it's gonna throw an error there.
Oh,
Or in the database?
That's a great question. I'm not sure off the top of my head. Let's take a look at the docs. If value is less than limit value. So my guess is that if we did something like this, so there is a min length validator, which seems a little more appropriate to a string. We can run this later. My first thought is what's going to happen is we get an error because min value validator expects an integer and this field is a string. So as soon as that input hits this line of code, it'll throw an error saying like, hey, I'm expecting an integer, but this is a string. Raphael, does that vibe with what you would expect?
I'm sorry, can you repeat that?
Yeah, Daniel was just asking what happens if we use like min value validator for a char field, for a text field. And my guess is that we'd get an error because the min value validator expects an integer.
That would be my expectation. I can't imagine it would do anything sensible.
Yeah, I think using min length validator, like we can check. I'm guessing that this takes a string. We'd have to maybe look at the source to confirm max length, min length, but that's my guess. Yeah, it's a good question, Danielle, excuse me. Did that make sense?
Yeah, thank you.
For sure. Yeah, what else is on people's minds? Okay, cool. Let's build another validator. Let's circle back to that account type. And actually, let me go ahead. Comment that out so our code is in a good state. This, like, I added a comment here, like this is, we really only want our account type to be two different things. And this is a perfect example of when to write validator code, because this would be a lot more effort and a lot more restrictive to try and like create this kind of rule in our database itself in Postgres. But let's write a validator so the account type can only be paid or free. And note that we have a convention for how we name validation functions. We just start it with the word validate. And then the name of the fields that we're interested in validating. Let's make a list of the valid account types. And this information might live somewhere else in like a real program. Like we might have a class or a map or a list that is from some other file that we import for this information. But for our purposes, this is perfect. And if it's not a valid account type, we just want to throw an error. Actually, let's make this an F string. And this is one of the really great things about like F strings and validation errors and writing our own validators and error messages. Like we can write user-friendly error messages that make life easier. Because I think we've all been on a website where like we entered something wrong in a form and it was really hard to tell why. And so this is our chance as software developers just to make people's lives a little bit easier. And then again, we can use this text function for internationalization purposes. And like somewhere else, we would have maybe like a list of these messages in different languages, and then Django could figure out which one to use at the right time. And that's really pretty much all we need. And note that with these validation functions, like we don't really need a return statement. We don't need to return true for the happy path when things are good. All that our validator function needs to do is throw an error if something is invalid and wrong. And the reason is that Django is using these in a particular way. And so it knows what the validation function is supposed to do. So that's kind of the pattern that we follow. And now let's go ahead and use this. And we can get rid of this comment because that information is captured in our code now. And use the validate account type validator. And now we're cooking it. We've got an account type validator. And next step is writing a couple tests and maybe seeing this stuff run and seeing this stuff work. Oh yeah, Dalton, so that's a good question about text. So it's just really a little bit of a preview of what's called a translation string. And they say it really well here. Like a translation string is something that tells Django this text should be translated into the user's language if we have a translation for that text. What Django does is it like extracts all of these strings into a file, and then translators can add like the same thing, the same message in different languages. And so this get text lazy function that I just called text with the as command to give it an alias to make it a little easier to use. What that does is that will kind of like build our message file. It's telling Django, hey, this is a translation string. When you use this, check to see, it's called the locale. And it's set on things based on like the user's IP address and stuff like that, or the user can set it themselves potentially. And then like if we were in a different locale, you know, like in France, then, and in our translation file, we had like a French translation for this as well. Django would use that instead of our English one. And that's something, I'm not sure how much we'll look into that, but it's just kind of a bit of a preview. Raphael, do we want folks to start using translation strings when they're writing validators and things like that? Is
I
that
don't think so. That's a step too far for us for this boot camp.
Yeah, I agree. I think that's a little out of scope. So I'll leave one here as an example. I'll just get rid of them because I think that'll make life a bit easier. And I don't want to add confusion. It's a good thing to know about. Certainly, if you can like talk about it during interviews, or you know, that's a plus, but it's not critical by any means. Let me make sure I removed everything I needed to with that. I think we're looking good. Yeah, what other questions do folks have? How are people doing? Is this stuff feeling pretty comfortable? Like a little bit, a lot, not so much? I'll take that as a yes. It's pretty comfortable and good, which is good. That's kind of what we're hoping. There's nothing earth shattering that we're looking at the moment. Yeah, and now let's look at tests a little bit. I don't think we've looked at unit tests a ton. But let's go ahead and write some tests for this. And apologies, I just had to get my Zoom out of the way there. And for that, we want to look at our tests file. And the way you write a test is we need a class. And this one is testing it's named apt user test because it's testing the user model that we just created. And we're going to bring in mock data through, I believe, this argument here. And here we can do some fun stuff. I need to import my model. And now let's go ahead and use it. See, what does it not like about this first name argument? First name is not defined, Pylance.
I think you meant to pass in the dictionary.
I may have, yeah.
Or no, I'm sorry.
No.
But it's the syntax. So yeah, just the equal signs for the parameterized or for the arguments.
Thank you.
Yeah,
Yeah,
that's what I meant.
thank you so much. Yeah, Python JavaScript, just, in fact, do people write, do folks do this in Python, or is that not?
I think I've seen that before.
I do that with JS. For me, it's like a lot. Actually, this is probably not a good idea in Python because indentation and white space matters. I'm going to do it for the moment just for writing it because I just get confused, to be honest.
Doing it like that is fine. I think it's part of PEP 8 anyways.
Oh, awesome. That is great to know. Thank you. So I've created a user. We have this class, this test class, and essentially Django using this test case library is going to execute this test for us. And a test is just a method. Really, the main thing is that we need to know if it succeeds or fails. And we're telling our test that we're expecting it to fail. And we're expecting it to fail because my age is 12 years old, which is too young.
What is the full clean?
Yeah, I'm gonna get to that in a moment. That's a really good question because there's a couple pieces there. I just want to finish off the just this test real quick. Let's see, how do I want to do this? Okay, yeah, we'll do this and we'll see how it goes. I might have to tweak this a bit. Yeah, and basically with every test, you're always creating some data for a test case. And you need to tell the test if you're expecting the test to succeed or fail. And if it fails, it's going to throw an error. And then we need to tell it what error we are expecting to see. And this full clean method. Yeah, let me just pull up the docs for that too. That's a good question. I was looking at that too. So, and this is actually really good to see, and I will throw this in the chat. I'll throw it in Slack as well. And I think that little bit is worth reading, and it kind of walks through what happens with validating. And just to repeat it, how does model validation work in Django? So it has 3 different steps. It validates the individual model fields. It looks at the model as a whole, and then looks at field uniqueness. because maybe the email address has to be unique, and that's a validator rule that we've added, or it's a rule of the model, and it probably needs to look at the database for that. And so I think clean here is used as a verb, like here, this validate model fields, clean fields. I think clean is in like check each field and make sure it's correct, like as in clean, and dirty maybe being something is not valid. And so I haven't ran into that particular terminology before, but I kind of get what they're saying. So this full clean method applies like all the validation of steps that can occur to a model. So it's kind of just like doing like a full 360-degree validation on the model. And Django should do a lot of this for us. It does give us this note that it's not called, when we use a model, save method. So that tells us that like when we're using validation, we may have to call the validators ourselves. And Raphael, I could actually use your insight there. I'm a little surprised by that. I would have expected the save method to automatically perform like validation.
I agree with you. I also think this is a little bit surprising. It's different from how I've seen other ORMs work in the past. So my expectation is that if you write a validator for a particular model, it should be impossible to save data that doesn't pass that validation. That like the save method and update, everything else in the ORM should be using your validators so that it's like always maintaining the integrity of your data. For whatever reason, Django doesn't do that. And so even after you write all these validators, it is still your responsibility to call them. Django still allows you to create invalid data in your database. Fortunately, you don't have to call all your validators individually. You can just use the full clean method, which calls all of your validators. You pass in a list of them, and so it calls them all one at a time. So it's not too much extra work for you, but it is still a little bit unfortunate that that's something you can potentially forget to do. If you create records in your database without calling full clean.
Yeah, I concur. It's annoying. It's like once you start doing it, then it kind of becomes second habit. I would have expected it to work a little differently, and maybe it gives us a little extra flexibility.
I guess the flexibility is nice. Like sometimes, like as part of the validation for one object, it has to refer to some other object. The part of the validation for that object is it has to refer to the first one. So it's like impossible to create something in a valid state, but you can like maybe create an invalid object and then edit it to become valid. So there might be some reason why Django lets you choose when to run the validators, but I can't think of a specific situation I've been in where I needed that ability.
Yeah, I agree. Everyone, there undoubtedly was like a big conversation about this among the Django team when they did it, and I'm sure they have their reasons. And this is like why I've kind of discovered over the years that like when I'm learning something new, just kind of like glancing through docs as we go is a really helpful tool. And the more you do it too, you kind of learn what to look for. Yeah, so that was a really good question, Alicia. And what I want to do now is I want to run our test, fix any issues it might have. And then I think we'll take a break, and then we'll kind of start looking at how to do some more things with validators and some things with like associations and models. So let me go ahead and run this test. And let me make sure that I've got the right command. And let me make sure that I'm in the right spot. And again, we use manage PY. So this seems great. It tells us destroying test database, creating test database. This is kind of how tests in Django work. And in most like web frameworks, like it will create test data, and here it's creating a database just for the tests. And let's make our test a little more interesting. Let's see what happens if instead of age 12, it's age 14, and I run my test now. Okay, now my test fails. And it gives us this pretty verbose error message. It tells us the name of the test, sort of gives us the namespace of the test. It gives us the file of the test, which is great. And it tells us the line of code right here where there's something going wrong, because we are expecting our code to fail there, if that makes sense. And kind of flip it around. I actually need to do a quick Google. Make sure I'm using the right thing. Maybe we don't have to force it to fail at all here. Maybe I think, yeah, I apologize. I think we just need to use full clean. Let's see what happens now with our test. Right. So our test now is saying, hey, here's a user, their age is 14. Let's create a new user and run this validation on them. And we have this full clean in this try catch block in case it throws an error. Because all of this data is good, no error is thrown. If I change my account type to something invalid, we're now going to see an error and we're going to see our test fail. And we see an error here again. And there's a bunch of stuff, blah, 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 blah. We see the error and the error message. But our test also tells us, hey, I was expecting to see a different error message if something went wrong. I was expecting to see this error message, user cannot be under the age of 13. But that's not happening. So our tests can both confirm that our data is good and that we're seeing the error that we expect to see happen. And I mean, it depends how comprehensive you want to get. But this is a good, this is a good example of like a basic test. Like we might want to write a test for each field here, depending on how rigorous we need it to get. So I think I'll just leave that example as like a basic example of a test and kind of just walk through that again. We want to create a user, the data that we care about. We want to then run our full clean validation method on the user to perform all the validation. We want to tell our test if we're expecting it to fail or not. And we want to check if it fails that we're seeing the error that we want to see. So like this test test that age validation. That's what this test does. And then we might want to create a whole new test to confirm that, like, say, the account type is working. Yeah, let me pause there and check in with folks and see if people, before we take a break, if folks have any questions around kind of the basics idea of testing or anything else that we've been covered.
So I wanted to know what specifically the e.message dict was referring to, was my first question.
Yeah, for sure. I actually need to double check that to make sure that I have that right. I'm pretty sure what's going on there is that, so the E, I can walk you through about half of it for sure. E is just this variable that we created for our error message where we say validation there as E. And I need to look at the validation error documentation, but just based on that, I'm 90% sure that a validation error has a dictionary that they call message dict, and that it, for Django, does a bit of work and says, hey, if validation fails for the age field, let's stick in the age, let's create an entry in that dict, like where the key is age and then the value is the error message. And let's look at our validation error code to confirm that right now. Validation error.
Because it looked like your error message was literally just printing that exact line, which didn't seem like it was doing anything for you.
Say that again.
So it seemed like when it did fail, it literally just printed out like line 22 after the inside the parentheses, that exact thing. Like it looked like e-message dict age did not like calculate into anything or add any additional data or anything. So I'm still confused on what that section is doing.
Got it. Yeah. And let me make sure that yeah, you're right, because I apologize. Because that's certainly not what our age validation message is saying. I may have goofed here. Let's see. User cannot be under the age of 13. Yeah, actually, Raphael, I could use some help because I thought I understood that line and I don't. And I think we may need to tweak that line of code to make it do what we want.
So what's the issue? What happens when you run the test? Like what's actually in the error message you get?
Now, let's see. So that's our happy path because, but that's not the test file. That's our happy path because we're expecting things to fail. And then we get this error message. Our unhappy path. That's not what I want. What I thought was going on here is I thought that, and I realized I was totally wrong, is I thought that we were like comparing the error message returned to this string and asserting that they're the same, but that is not correct. I think, let's do this. Why don't we print?
Always a good idea.
Yeah. Okay. So this is our print statement right here of the age message. Which is what we're expecting to see because the user is too young, and that's the error message. Right, okay. Okay, I got confused. I see what's going on here. Let's try this. I think I know exactly what's going to happen now. Yeah, true is not false. Okay. Okay, I apologize. I had it backwards. So, Alicia, thank you. That was a really good question. Yeah, so there are two pieces going on here. The first one is we have our validation error, and it has a dictionary called message dict that Django gives us. And I'm pretty sure what it's doing is any validation errors that appear when we run full clean get thrown in there, with the key being that the field in question. Like for instance, here, we now have two errors. When we run our test, we'll be able to see it. Oh, right, because in fact, we could just print the whole dictionary, but that might not be, I'm not sure if that's going to be readable. Right. So here are the print statements. And so that confirms what I was thinking, that this message dictionary contains all the error messages that happen when validation occurs in a dictionary. Does that part make sense to folks?
Yeah, so you're saying this is the error message I want to throw, and I want it to stick that value in this dictionary with the key of whatever I'm putting as the key.
Yeah, exactly. And Django does that work for us. Like the key here is the name of the field that the error happened, that the validation error happens for.
Yeah, I was talking more like in line 24, right? You're specifying.
Oh, I see. Right here. Yeah. So, yeah, and I had this wrong. I apologize about that. And this makes a lot more sense for this test. What we want to do here is this test is supposed to fail. Is supposed to throw errors. It's supposed to throw an error for the sorry, I'm going to change this back to something valid just so I don't get confused later on. So this test is supposed to throw an error on the age property because the person is too young and it fails our age validator. We want to confirm that that happens, and we want to confirm that the error message is what we expect it to be. And that's what line 23 is doing. This assert true statement is saying, hey, I'm expecting to be true that this string message, you need to be 13 years of age or younger, exists in the actual error message that gets generated when we run the test. And
Okay, so I'm still getting a little confused because I'm just
Yeah.
comparing what you have here to like the notes that we have for the day. And so if you could explain a little bit more, when are we putting self dot assert true and false? Because right now you have true, but the notes show that you want to have false if you're putting a number under the appropriate amount. So if you could just explain that a little bit more. And then also, what is the self dot fail doing? Because the way you're talking about it is almost just seems like, what is it doing? Is because it seems like your comment of it should fail here would be just as appropriate as the self dot fail from what I'm seeing.
right, for sure. Let's look at the self dot fail first. So I'm pretty sure I know what's gonna happen here. Actually, I was totally wrong. I do apologize. This fails. Self that failure message here. Yeah, Raphael, I'm not actually sure what self.fail is doing. I apologize. I thought that what it did was tell the test runner that that it should fail, that failure is what we expect, essentially.
So that line isn't declaring expectations. It doesn't say what should happen. That fails the test at that line. Like if line 21 executes, then the test has failed, does not pass. Which is intentional. That's the point. That's what we're trying to achieve here. So like, think for a minute about what we're actually testing here. We're testing our validators for the ORM. And what they're supposed to do, these validators, is if they work successfully, they're going to do nothing. So if they work successfully and we give them valid data, they do nothing. If they work successfully with invalid data, they should throw an error. If they work unsuccessfully with invalid data, they might not throw an error, or they might throw the wrong error. So like in our specific example here, if we try to create a new user that has, age of 12, for example, and then we call full clean and that doesn't throw an error, then just like following the code, that's going to be the end of this test. And it's not going to raise an assertion error because line 23 is never going to run. So to repeat that, if we don't throw an error in a line 20 or 21, then line 23 never runs because that's how try except works in Python. But if we think like logically about our code and what we're trying to achieve, if we try to create a new user who is below the age of 13, and that doesn't throw an error, then our code is not working the way it's supposed to. It's not working properly. So like I know that if we get past line 20 with a 12-year-old user and Django doesn't throw an error, I know that that's incorrect. And so I'm going to manually throw an error at self.fail on line 21. So that way, by manually throwing an error, it takes us into the accept clause on line 23, and then we can actually check if the error message is what it was supposed to be. But
Yeah,
if it doesn't throw an error in the try clause, then we don't check anything, and that test is going to pass regardless of what the validator is actually doing.
okay, thank you.
So-
Yeah,
so
Alicia.
maybe seeing the error again and where it's supposed to print out, because I'm a little bit confused on the fact that we keep seeing the error that you're telling it to print on line 23, which is what's supposed to happen. But how do we know if it's happening from our try from line 20, or if it's happening because we're saying print this error message.
Right. Right.
I mean, the only place where we specify like to print that error message is in the models file where we're defining this validator.
Yeah, yeah, I think I see what you're saying, Alicia, and Raphael, that's helpful. So, and Raphael, just to confirm, so line 21 is basically a fallback where if something goes wrong in the wrong way, the way we don't want, we want to force a failure rather than silently continue with stuff being wrong.
Right.
Yeah,
It's just kind of tricky in this case because usually when you write a test, when it doesn't throw an error, that means that it was successful. And when it does throw an error, that means the test failed.
yeah,
But for this test in particular, we are testing our ability to throw specific errors. So just the way we write the test is a little bit awkward.
got it. Yeah. Yeah. Yeah, I mean, I'm wondering if we could refactor the test. And Alicia, as to what you're saying, I think that, like, for example, if we have, let's just say like a bad email address.
Because like for line 23, you still have self.assert true, and then the notes have self.assert false.
Yeah,
So I think that's kind of still giving me some headache there.
yeah, I got confused there too. And Raphael, am I correct in thinking that the notes, like, this is how I would write this test to test that, like, our validator functions. That assert false, so that in the notes that's going on, that doesn't, I think there's an issue there.
Yeah,
But
that might be backwards. I think you've got it right here.
yeah, Alicia, I think the notes are incorrect is what's going on. And the reason I figured that out is because the string that's in the notes, like, it doesn't show up, that's not what we're actually writing now. There's two ways to do assertions. You can kind of confirm that what you want is there, or you can confirm that what you don't want is not there. And each has their time and place. In this case, what we want to do is confirm that what we want is there, that we want an error message to be there. We want it to say this specific thing, and we want to assert that it's true that that exists. And that's the purpose of this line 23 here. And does that make sense? Let me actually just pause there. Does that part make sense?
So that part does make sense. I
Cool.
think to put it all together, I would need to see it ran again and look at the error code and what we're looking at.
Yeah, totally. And we can write like we can write,
Because the other kind of confusing part is, I mean, unless you changed it, let me go back. Because I'm looking at, yeah, because the other confusing part is if you're saying line 23 is verifying that the error that's in the message dictionary is the one that you specified you wanted back in the models.py file,
mhm,
then I'm still confused because the error message that you typed here is the one that's in the notes, but in their test section, they don't have the same message.
yeah, and I think that's also incorrect. I think both the assert false and the message from the notes are just incorrect, and we need to update that. Because I'm pretty sure, and let me go ahead and do this. And like, what this is good for is like, let's say that we've changed the error message or something. we want to make sure that the error message is what we want it to be. And so now I run this test and it fails. And kind of again, going from the bottom up way of reading error messages, it's this assert true statement. And it is tricky to read, like false is not true. Like it's a weird way to read these messages. But what it's telling me is that it's expecting to see this message, but it doesn't get it. Or like, sorry, I was trying to connect it to a real world use case, but I think I was just going to make it more confusing. But that's kind of like the purpose of this line here. Like, I think the way to really think about it is like, let's say this is what we used to have. This was version 1 of this error message. And then a product manager was like, hey, we need to tell the user their current age because we're getting complaints for some reason. And our tests tell us, hey, this new change that you've made isn't reflected. I'm not seeing it. And then we're like, oh, we actually didn't update the code.
Oh, can you just show us again? Can you run the test again and say right here in this block is where it's showing us line, line 19, where
Yeah.
it is in fact confirming that the test is working correctly. It did fail. And then on line 23, where we would check, okay, this is also working correctly because the error message in this dictionary is the one that we wanted to be in the dictionary.
Yeah, you mean confirm that we're getting right. And in fact, what's happening is, I think, and Raphael confirm if I'm understanding this right, like this is the core test logic right here. Actually, we're depending on the error message for everything for this particular test. Let me put this back into a good state. And I saw some other folks have their hands up, and I'll check in with you folks too in a moment. Like when our test passes, the reason it passes is because we are handling an error, and this assertion says, hey, I expect the error message to be this, and it is that. And that's the part that's okay. As soon as I change something here and run the test again, I get a failure. And the failure is from my assertion here, because it's doing this direct string comparison and it's saying, hey, I was expecting to see this, but I'm seeing something else. So this test fails. And that's all that it's actually looking at. Like if I'm understanding this correctly, like I have the account type wrong here. In fact, like we could do a lot of other stuff. Let's see, the account type is wrong. The email is wrong. So there's a lot of stuff that's wrong with the validation, but our test doesn't check any of that. And so it's like the only thing this test cares about is the age error message. And that's the only thing that it's testing. Like, do we get an age error message when I expect to, and is the error message what I expect it to be?
And you typically write it in the 2-chunk fashion like that.
Say that again?
You would typically write it in kind of those pairs of, is the error message happening and is it the right one? And
Yeah,
then I imagine you could just print e dot, wherever it went, e dot message dictionary age if it was the wrong one, and find out what's actually being printed there.
yeah, totally. And that's, the
Okay.
test runner should do that for sure. and I'm sorry if I misunderstood your question too. And that's, I think, like, that's what our test runner kind of does right here. And you're right, like it looks like right here, actually further up in the air, it's printing out that entire message dictionary for us to read as kind of part of the traceback. And you're right, it doesn't print out like the other part here. There might be a setting that we can use to do that. Yeah, and we could totally add a print statement too if we needed to. And I do that all the time too when I'm working on tests, if I need to understand what's going on. And there's a lot of different like approaches to writing tests. Like Raphael, would you include like multiple try and accepts in like one test run, or would you create a new method for each field of this user to test?
I would create a new method for each field, I think,
Yeah,
but it's kind of subjective. It depends on what the code looks like at the end of it.
yeah, like I'm actually not sure what the right. I'm not sure if this is the right way to name something, but let's like name this account type. And it doesn't really matter. So this is a test. To test the user account type. And I will need to fix this. The test isn't done yet, but I just want to go ahead and run it. Excuse me. And it looks like I have a typo. And it looks like right. So at the end of the test run, it tells us it ran 2 tests. It tells us 1 failed. Excuse me. And this is the account type message. And I'm just going to borrow it from here and put it in the test file. And sometimes this is the easiest way to build these kinds of tests. And now, I think this test will actually pass. Oh,
Careful with your quotes.
yeah, thank you. Do I use a double quote or should I / them?
I would enclose the whole string in double quotes and then keep the single quotes on the inside. Because that's actually going to be like character matched, literally.
There we go. Thank you, Raphael. Yeah, and so this test has the exact same logic as the age test. Except we're doing it for user accounts. And then maybe let's actually test like the happy path, which we haven't really done. And for the happy path, do we want to throw this self.fail for a success case test, Raphael? I feel like we don't want that.
I mean, is it supposed to throw an error?
It is not.
Then I guess you don't want to do that.
Yeah, thank you. Yeah, I'm not actually sure. Yeah, I probably am structuring this wrong, and I'm sure we need something in the accept clause here.
So in this case, if your intention is that it shouldn't throw errors and that throwing an error means that the test failed, you don't need try except at all.
Okay, and the test, okay, thank you. And then the test, okay, right, and the test runner will catch it. Yeah, and then like what we might want to do then is save to database, confirm is correct, or something like that. Your next step. Enter a valid email address. Oh, because the email is wrong. So this is actually a great example too, and you were kind of talking about this, Alicia. Like this test, I want to test that like the user account type creation is working correctly. But I have the email wrong and it threw an error. And we got an error message, and here we saw the full validation error, and we see that whole like message dict right in here, and it tells me what the issue is. And so I might do this. And I might do this for like another user for the free account type. And there are ways to write these tests better, but now we're testing that like our logic correctly handles both of our desired account types. And we test that we throw an error that we expect for an undesired account type. And this isn't a bad sketch of different testing approaches. And I do want to, yeah, go ahead.
Well, I realized Dalton still had his hand up, and I didn't want to. Dalton, did you want to ask your question first?
I mean, it's just really quick. Like, so I still don't get, no matter how many times you explain it. Like,
Yeah.
it seems like if you ever put self.fail in a test, like, doesn't that nullify the purpose of testing? Because aren't you trying to make sure that you actually get the error message instead of forcing it to give you an error message? Like,
Right.
Isn't that the point of testing?
Right. That's a really good question. And to be honest, I got confused on that as well. So like for tests where we want a failure to occur, like these first two tests, essentially what happens if, let's see, for create user, that's looking at the age validator. What happens if I modify my code and I make a mistake and like age is less than 3? And oh, sorry, this is the challenge with tests, is that like then one test failure can cascade. Let me fix this really quick. Let me make sure that's good, and fix it here. Let's see, where did this one fail? Account type foo is not valid. do that. Thing. Let's see here, self.fail, it should fail here, right, because we got the failure. Okay. Okay, let's try this. I get rid of the failure. Run the test. Let's see, where's this error coming from? Line 37. I think I'm just going to very quickly comment out. I know there's a way to run an individual test file. I don't know it off the top of my head. Let's see, so get rid of that one. Get rid of that one. And I'll do this sometimes too when I'm working with tests. So now we just should be running the one. Okay, I apologize about that. So I'm sure there's a better way to do that. So right now, I've got just this one test running. I wanted to catch the age. I'm expecting it to fail. I don't have this fail call here running. And the reason it's passing is because I've changed the minimum age to 3. And I haven't, because of a mistake that I made and I updated the test, or even worse, instead of changing the minimum age, maybe in my model, I forgot to add the validator. This test passes just fine, but we actually have a problem. And so, like, when we know that a test is supposed to fail, and Raphael, please let me know if I'm explaining this wrong. My understanding is essentially this self.fail is like a fallback. Like, we know this test should fail. When the test is working correctly, it fails on line 19 because the validation fails for age. But if we have an error somewhere else and we don't know it, this forces a failure. And then we get an error message and then we can see what's going on. But if we don't have that, like, a failure is never forced and the test passes, essentially now we have like a silent failure. Like, something is wrong, but we don't actually know it. Does that make sense? Yeah.
Wouldn't you know that the test, like, wouldn't you know that you have a problem because you're the one that wrote it and you know that it shouldn't be passing? So you wouldn't that tell you by its own that, like, oh, hey, I must have messed something up. It's not giving me an error.
Right. So
That's
yeah,
way too much effort.
yeah. and-
Imagine you're gonna have like 1,000 tests running. You don't
Yeah.
want to like remember what your assumptions were for each one. Your command line should tell you what's wrong.
Yeah, and also bear in mind that like this test is supposed to throw an error, but the test passes when it throws an error because we handle the error, and then we have really what we want is we want an error to happen, and then we want to check the error to make sure it looks like what we expect. So like throwing an error is part of this test passing correctly. What we don't want to have happen is like not throw an error, and then the test continues on and passes and we don't know it. Sorry, I don't know if that makes sense. I don't know if I explained that the best way.
It does. Yep. Thank you.
Yeah, for sure. It's confusing too. Like it takes a minute to kind of have it make sense. So it's a good question. Alicia, one moment. I know Rexford, I think you had a question earlier, and I think there was someone else.
Yeah, my question was kind of similar to this same question you just answered. I was having a hard time seeing the purpose of line 20, but I think I understand it now.
Yeah, yeah, for sure. And it, yeah, no, and that makes sense. And I misunderstood that initially and explained it the wrong way. Yeah, basically the purpose of line 20 is like, so for these, ooh, excuse me, like for tests where we're looking at, like we'll talk about like the success case for a test or the failure case for a test, or for, not for a test, I'm sorry. We'll talk about like the success case for like a method, or a failure case for a method, or like the happy path or success path. And we test different parts, right? Because with validation, sometimes we want to make sure that like things work correctly as we expect. And sometimes with validation in particular, to make sure that the validation is working, we need to force a failure and then confirm that our validator is catching the failure and doing what we expect with it and catching it for the right reason. So like this test is testing like a failure case is kind of how I would say it. And what determines if the test passes is no unhandled errors are thrown and all our assertions return true. So we're handling all this code in a try catch. So whatever error happens when we run our validation with full clean, that error is going to be handled, even if it's an error that we don't want. What we also do is in our error handling code, in our exception code, we have an assertion to check the error to make sure that it's what we expect. Like you might even check the other fields of the error to make sure that there's nothing there if you want it to be like really verbose. There are a lot of different ways that people like to write tests. So let's see, sorry, I lost my train of thought for a moment because it does get confusing to talk about. But essentially, like for tests where we're interested in the failure case, we need to make sure, we need to force an error if it doesn't happen, because we don't want to suddenly have this test pass and our validator isn't producing an error when it should be. So for a test that should always like throw an error, we want to add self.fail to like force the error. And then in our exception handling logic, we can interact with the error and confirm if it's the right kind of error or the wrong kind of error. Sorry, that was a really verbose way of talking about it. I hope that it helped a little bit. Alicia, what's up?
Yeah, so my question is going back to what we learned about how it won't. So I imagine this is like verifying that when the user, right, puts in this information that it's going to be correct. But your point of, you know, the information that you're putting in your database isn't getting checked without the full clean, I think it's called. So my question is, after you create your entire, because it's not just going to be, you know, one time you write Adam Cahan age 12, right? You're going to potentially be putting in thousands of people with thousands of ages. Are you every single time you write somebody's age running full clean before you put that in the database? Or is it like you write these tests and then you go to write one additional entry and before you insert that extra line, you're running the full clean on that entry? Or how does that part work?
Right. That's a great question. I don't have a view built here. So you're right. Like every time we create a new user account, which means adding a new user row to the user table in the database, we're using this user model and we want to run the full clean method. And the way that we would do it is that like we would have one place in our code, like one method that is responsible for creating a new user in the database. And we call full clean there. And so, yes, you're correct that every time a new user is created, we need to call full clean. But like we can use like writing a method that can be imported and used in other places so that we only have to write that code once. It's not quite that perfect with tests, and there's always kind of times when you have to do it manually, but that's, if I'm understanding your question, that's the general approach.
Okay, I mean, not that I'm necessarily complaining if this is the way that you have to do it, but it kind of sounds like you wrote like, 5 tests for one user. And so then every time you make a user, you're running all those 5 tests. You can't just like input a whole bunch of people
I
and
see.
then it'll say, sorry, you messed up on Susie because she's only 4 years old trying to get a dang Twitter account.
I see. Okay. Are you kind of asking like, do we have to run these tests when we create new users?
Well, I guess I could be asking you. I thought the answer was yes, we have to, because the line we read online said it's not, the save isn't going to check it for you. You have to run the full clean. So it would
Got
seem
it.
like there's so much time, not even just creating your entries, but then also testing every little, not that that's a bad idea, but is that really the way it is then? As we write all of these tests, we make one row of code, we run all of the tests, we move on to the next row of code.
Got it. I see what you're saying. And no, that is not what we do. And you're totally right that that would be a whole lot of overhead. And I think I apologize because I didn't explain it well. The full clean method runs all of our validation logic that we write in the models file.
Wait, say that one more time, sorry.
Yeah, for sure. If I'm understanding it correctly, and we can double check, it's somewhere around here. I have too many tabs open at this point. But full clean, yeah. So what this full clean method does is it runs all of our validation logic in our models. This code over here. Full clean is not really related to tests that we write. The tests that we write aren't about like adding new users to the database or like the actual application in production. The tests are what we use to confirm that as our application grows more complex, like it's doing what we expect it to do. Like we create sample cases and then we use those tests to run it. But full clean just runs this validation logic in our models file.
Okay, so I think what you're saying is in line with what Michael's saying in the text, is that basically these tests are just checking that your model is working when something's input, but then I'm still confused about the line that you and Raphael were talking about, is that you can't just save, you have to run full clean every time.
Right. That makes sense. And that part is a little confusing. Yeah, so you are correct. And I think, Michael, you're correct. Like these tests.
But also you are testing it when you're making a user. So
testing what when we make a user?
I mean, you're testing making a user right here. So never mind.
For clarity, the tests are not
All right.
part of the application. This file tests.py, this doesn't ever run just when people are visiting our website or signing up. This is something that we as developers will just run periodically on our local machines to verify that our code is working correctly. But all this code you're seeing here in test.py, this doesn't run regularly when users are signing up for the site.
Thank you, Raphael. Yeah, and I did kind of jump. I
So
kind of.
what I mean, like, so like, let's say, I mean, that sounds like that would be fine if you're creating a database with literally zero pre-existing data, right? Like you get a client, they've got no clients, you're creating your database. The very first time a client is entered is online when they go in and they put in their data. But what if you show up with a client, they're a dog walker, they've got 10 clients, they want to create a database with those 10 clients, and you don't have to go through filling out the form every single time on the website. You want to just in the back end, put them all in the table and then start fresh from there. So how do you validate that data if you can't just hit save?
That's a great question. I haven't done that before, but there probably is a way to just use save in that case. You should be able to load all the users as, you know, Python objects as class instances and then call full clean on them. So I'm not exactly sure what the code would look like, but you should be able to leverage all these validators, whether it's for a single user registration or for like a bulk user upload.
Okay,
Yeah.
I'm sorry to like beat a dead horse here.
No.
I just want to make sure I understand it.
For
So
sure.
right now, we wrote our models, we wrote our tests to test our models. In theory, if we were to go online and create a new user and we put in the wrong data, we should throw the correct error because we've already tested our models. But right now, if you were to create a user just in Django, without running your test, and you just hit save and you put the wrong data in, is it going to throw an error?
I see. Yeah, no, and that's really good to walk through like that. And yeah, so to answer your question, the flow will look like this. I'm logging on, I'm creating a new account on Twitter. I enter my information in the form, I hit submit, it goes to, you know, our route and our view and like one of our route handling functions. We take that data and we use it to create a new user model. And at that point, it's totally going to depend on what we do in our code. If we just go ahead and do like new user.save, then that information gets saved to the database and none of this validation in the model gets run. What we want to do is we do have to manually go new user.full clean and do it in a try catch block to handle any errors that might pop up. And that full clean method runs all of this validation in our model file. If there are no errors, then we do new user.save and save the user that's been cleaned, quote unquote, now or validated to the database. And the tests that we're writing don't factor into that process at all. Does that make sense?
I think so, and maybe the homework will solidify it.
Yeah, and this is honestly, there's like the validation stuff, like I could tell that folks were pretty comfortable with it. But it makes sense because talking about testing and then talking about that there's an extra step with the validation. And again, I think it echoes a lot of what we were seeing in the assessment 3 retro at just like looking at the flow of how is information like moving around in the program. And there's a lot of moving parts there. I think we should break for lunch soon. And Raphael, I'll check in with you about if we should do a breakout session, because I know there were some things I didn't get to, and there might be some things that would be useful for folks to cover. But we'll be around to after lunch to work on this stuff in homework. And I think starting to build it, a couple examples will help. Just to wrap it up, I think the 3 main points that I think will be helpful is that this full clean method, and you can see it because like if we look here in the docs, we can see exactly what it does. It calls these other 3 methods, and they're all methods on the model class. So everything related to validation and related to this full clean method is about like running the validators that we create on our models. And the way Django works, that's something that we just have to make sure we have that line of code before we save like a model instance to the database. Because there's nothing stopping us from doing that. And then the tests are not about like our program that's running. And Alicia, to answer your question about what if I want to do a big batch import of data, essentially we would like write a Python script that imports Django and uses models and uses full clean and uses model.save. What tests are doing is we're just creating like a tiny sample like of a real situation. It's like a simulation. And we're confirming that our code does what we think it does. And the tests aren't meant to be used like in any sort of real world scenario. And it's a little hard to do to understand like why they're needed now. But imagine if you have 200 models in a Django app, for example, and each one has like some complex validation, and you have a team of 10 developers who are making changes every day. That's when having tests is really valuable because we all make mistakes and we can miss one. And what the tests do is they're like guardrails. Like the flow is I'm working on a feature. And before I like add my change to GitHub, I'm going to manually run those tests on my machine. Or even better, we can configure GitHub to run those tests in like a server somewhere out in the cloud and for us to make sure that like we're not pushing code that accidentally breaks something into the code base. So the tests are like guardrails, I think is like a good metaphor. Like, and they're not about when the application is actually running, and we don't do anything with the tests when we add real information to the database. Yeah, I know that was a lot of stuff, and you folks have been asking really good questions about this stuff too. So thank you. I really appreciate that.
Yeah, so there's definitely been a lot of great questions, but I think we're a little bit overdue for lunch at this point.
Yeah,
So
and we have a meeting. Yeah.
Also have some meetings. So I think we're gonna have to come back this afternoon and do bonus part 2 of this lecture. So I know, everyone's just so excited about our content today that.
Okay. So yeah, I'm glad we had a good break and definitely a good time for it. We covered a lot of ground this morning, and thank you folks for asking a lot of questions and staying engaged and being, excuse me. And thank you for being patient with me at times. We talked a lot about testing, and I kind of want to just shift gears to look at how we can use the Django ORM and Django models to create associations like we've seen with SQL with foreign keys and primary keys and things like that. And to get that ball rolling, I think what I'm going to do is I want my notes, which are in the wrong directory. Apologies. There we go. Okay. Perfect. And for simplicity's sake, I think we'll just start a whole new Django project for our associations, because we're going to be looking at a slightly different example with a school. So I'm just going to go ahead and get that going very quickly for us. And truth be told, this could probably be done as a Django app within our project. But just for the sake of simplicity, I want to do it as a new one. Let's see here. Cool. Go to now. Go to the demos and notes. Put it all in here. We'll rename the folder later. Gonna install Django and the Psycho PG2 dependencies and just do that. Install both of them in one line. Looks like all of that ran successfully with the normal warning that I have to update pip. Make sure I'm in the directory I want to be. I am. Create a project named school. Let's see. That this database already exists. Yep, so we'll call it something else. School 2. And let's quickly change what I need to change here. And in the settings PY, I'm just updating it to use the school tool database. We're probably also going to want a Django app. So we've got that. And let me update my settings PY with that as well. And now we should be good to go. And now we can start
Can you
creating
do
some
the
models and
settings?
associations. Sorry?
How often do you have to do what you did in the settings folder, changing the default to whatever?
Oh, for the database?
Yeah,
Yeah, that's a great question. I believe there's only going to be one settings.py file per Django project. So you should only have to do it. So every time you create a new Django project, you will probably have to make this change. I don't think you have to make that change at the app level, like creating multiple apps within a Django project. But yeah, every time you make a new project, you would have to, in the settings, tell it what database you want to use. And then if you add an app, add that in the installed apps list as well. Yeah, that's a good question. There's always a little bit of ceremonies, one word that we use, boilerplate, just kind of like stuff like that. It's good too to keep that stuff in like a notes folder. Just the kind of like common steps for spinning up a Django project. Like here, it's pretty straightforward, but especially say like when you're starting at a new company, starting up their system, sometimes there's a lot of steps. So for the first like 6 months, it's really helpful to just keep notes, because sometimes like your other teammates have been there for a couple years and they kind of have it all memorized by now. I probably need a comma there, actually. And I'm going to go ahead and open up the models directory for schools. And now let's start building some stuff and some associations. So Django associations. We are going to use Django models and the Django ORM to build the same kind of relationships we saw with like foreign keys and, well, really mainly with foreign keys or join tables that we did with SQL. But we're going to have the ORM do that work for us. So we're going to use Django models to build relationships between our models, SQL tables, which store their data. There's much 3 kinds of relationships: one-to-one, one-to-many, and many-to-many. And one-to-one is less common and usually done with a foreign key. One-to-many is fairly common, and this is often done with a join table. Well, actually, I should rather say often done with a foreign key, possibly a join table. And many-to-many relationships are also pretty common. And the cool thing is Django ORM is going to do the work of creating the foreign keys and even join tables for us. And we're going to use the same data model that we've used for a while here. Sir, and we'll give them, you know, first name. Let's see here. I need to make sure I get this right. Models, char field. I can never remember this stuff. I always have to look it up or just grab an example from somewhere else in code and copy it. The last name just to give them some information, just to get the ball rolling. And the professor is going to teach some courses. And the course is going to have a name. And a lot more interestingly, a course is taught by a professor. And so this is our one-to-one relationship, I believe, done in SQL with a foreign key. And now we're going to see how to do this with Django ORM. And I think you folks will be just very happy about how straightforward this is. And there's more than one way to do this. This is, in fact, a bit more verbose. And we're going to see a somewhat simpler way to do this in a minute. So breaking this down, when we use this models.foreign key method, we're creating a relationship between the course and the professor, right? Where a course now has our course table will end up with a column named professor, which is a foreign key pointing to whatever the professor's primary key. And just like Django models takes care of creating a primary key for the professor table in the database for us, it's going to take care of connecting this foreign key to our professor's primary key, because Django ORM knows that by default, it should look for the primary key of the professor table and connect the two. And then there's two other things that we add here that are interesting. So we have these two other arguments that we pass into foreign key. This on delete one is really interesting and powerful. What it does is it tells our model what to do when the professor is deleted. So on delete here is referring, I believe, to what happens when the professor that teaches a certain course is deleted. And what cascade means is, oh, they don't tell us. Essentially that it deletes all the courses that the professor is teaching. And I apologize, this is actually not a one-to-one relationship. I totally spaced out. This would be a, in sense, a many-to-one relationship. One professor can teach multiple courses. Each course only has one professor. So if Professor Xavier leaves the school for mutants, then when we delete his record from the database using our model, this cascade behavior comes into play and looks for all the courses that Professor Xavier is teaching and deletes those two. And all that happens automatically. Does that make sense to folks? And are there any questions about that?
So in your table, would it just leave like a blank value there if you deleted a professor?
That's a great question. So when a table is deleted, actually ask the question one more time, please. Say that again.
So if you deleted the professor underneath your table, that foreign key that was pointing to that professor, now that foreign key doesn't point to anything. Is that correct?
Even more so, the whole row is deleted. Let me do a quick visual example here with our trusty friend, the spreadsheet. Of course, and really all we need is name. Let's make that big, make that underline.
So it sounds like that primary key no longer exists, and any corresponding primary keys no longer exist in other tables for that, for the professor. So in those tables, the primary keys just skip a number?
Oh, the primary key would probably skip a number indeed. That's something that the database would take care of and whose behavior shouldn't matter to us, but I believe that you are correct.
Okay.
Is there a way to assign assign alternates for stuff like this? So like if something gets removed, that we automatically replace it with something else?
Yeah, that's a great question. we wouldn't want to do alternates. Or if we did, we would implement that at a level higher than these database associations, because this is like a very core sort of behavior. But, and there's probably examples in the Django docs, but there's a Stack Overflow post that explains it very well. Ooh, excuse me. We have a bunch of options though, for how we want to handle on delete. It doesn't necessarily have to cascade. And this is a big part of database design. And to be honest, I'm not quite sure if we want to totally delete a course when a professor leaves, like maybe someone else teaches it. What happens to the students that are signed up? I think we're going to build a concept of like enrollments in a course. So maybe that data is stored there, but you know, we might need to have a course live on its own. But so there are a bunch of different options to do when like the relation in like a many-to-one relationship like this, or any relationship one-to-one, many-to-many deletes happens. Cascade is one option. And they describe it here kind of funny. When the referenced object is deleted, also delete the objects that have references to it. And their example is actually a good one. Like if you delete a blog post, you should probably delete the comments. Here we're saying, if I delete a professor, delete his courses. And then here are some other options. Protect. If there are courses running, this won't let us delete the professor until we get rid of the courses, which in certain situations might make, you know, there are very good use cases for that. Set null, I think someone mentioned this. And actually, I'm surprised to see this here. So if we did set null, when Professor Xavier is deleted from the system, then his courses are still there, but that value for who is teaching it is just set to null. And in fact, we'll just add it. It's a little confusing. I apologize to have the course ID there, but that's okay. So with set null, if we delete Professor Xavier, for these two courses, that value becomes null. With cascade, these two things are deleted altogether. Does that make sense?
Yeah, that was really helpful. Thank you.
Yeah, totally. Yeah. And Alicia, you're right. There is a set default option. Set the default value. I apologize. I totally missed that. I will say, I actually did not know SQL has a set default. I think that's really cool. I will say, I think that, well, it depends. It depends what you're doing, right? A lot of the times you want that in your application code. But if you're like provisioning school lockers or something, to use an example that we'll do in a minute, then there very well might be a good default value to set something to. There is a do nothing option. As they say here, it might not be a great idea because then you've got a table referencing something that doesn't exist, which would look like this. You know, but there is no Professor Xavier. There is no professor with ID 3. And then that's going to cause a lot of problems. That's the last thing that we want. So yeah, that's like the basic concept of using a foreign key association. And we can do it a bit more simply. So the last thing here, by the way, related name, this is optional, but I believe what this does is it builds like a two-way relationship so that like from a professor, we can find their courses. And I'm going to go on a limb here a little bit, but I want to test this out. And let's change this back to Cascade. Let's go here. Let's create our migration. Make migration. Yep, but it's not a Twitter app. It's the school app. So we've created the migration. Let's just go ahead and migrate. And we've gone ahead and done that. And let me see if I can pop into the Django console, because then we can play with this, I believe, if it works the same way that Ruby on Rails does. Let's see here. Oh, I apologize. I'm not gonna be able to get this working the way I want to in the next couple minutes. So we'll circle back to that, and I will try and throw something in the chat about that. We use on delete to say what happens when one model, our model refers to is deleted. And let me throw the link here too, so we have it in the notes. So we wouldn't write this code here, but just to give some examples of how we can manipulate this. We could do something, and this is what I wanted to do in the Django shell. And I'm sure there's a way to do this. And actually, if anyone knows, let me know. I've done this with Ruby on Rails. We can use it and start querying. So this would give us, yeah, I don't like just using C. Let's just do it, my course. This would give us a course with ID of 3. Printing out the course's professor. And if we wanted to get all the information on the course's professor, we'd do something like this. Let me make sure I have that right. Let's change this to just professor, actually. And this would print. All the courses that the professor is teaching. So it hopefully is pretty straightforward and feels pretty comfortable, folks. Let's take a look at how to build some more sophisticated models. And let me check in and see if folks have any questions or anything they'd like me to go over. Michael, yeah.
So those lines that you put where it's like my course equals and then the professor equals, does it print when you make the migrations or when you migrate, or when does that print?
Yeah, that's a good question. It really doesn't belong in here, to be completely honest. We shouldn't put that in the models file because we don't want it to be executed when it migrates. Like,
Imagine you do that in like your views or something.
yeah, you would do it in a view, you would do it in a test file. Let me see if I can't get this working in the Django shell because it is. Django GB input models. Let's see if this works or not. Oh. Did not like that at all, did it? Because it doesn't like this stuff in the models file. It's either I have a typo. But yeah, you would put this in a view. Yeah, I think I'm going to leave it here just for the moment, just to keep stuff in one file. But that's a good question, Michael. Yeah, you wouldn't like want code that is manipulating your models to be in the models file itself. Does that make sense?
Yeah, that makes sense. Thank you.
For sure. Yeah, no, and that's a good question because this is like a non-standard way to do it. Yeah, and after the lecture, I will follow up if there's a good way to use the Django console because that was one of the things I really did. I think Ruby did really well. Kind of going ahead and building out the school metaphor. Let me just add a note there too. Let's say we need some lockers. And a locker has a number. Locker's got to be unique. And just like we can with SQL, we can add uniqueness. It probably needs to be a capital T. Just checking for typos here. And I do have one right there.
Also, you have the O and L switched on locker.
Oh yeah, that's a classic. Thank you. And a locker's got to have a combination. And we're not going to use integer. It's just a little easier to use char field. And here it's saying max length is really appropriate for what we're modeling. So if the university ever gets new lockers that have a different combination, then we have to update the database, which stuff like that happens all the time. And we're going to want to come back and add a combination validator. Now, how we get the students' locker combinations is a great question. I suppose the lockers have to come with a default combination of some sort. So there's lots of interesting questions here that we can come back to later. And if we want to, we can even define a string method so that if this prints, it would return information about itself. Which might be nice. We might come back to that. And let's go ahead and create some students for our university. They're going to have lockers. They might even have courses. So 32 seems pretty good for a first name.
Hey, Alan, you misspelled number.
Say that again.
You misspelled number for
Oh.
locker number.
Thank you. Oh yeah, I totally did. Thank you very much, Maya.
There's a spell check extension, by the way.
I should probably get that. That would be good. Yeah, I use the IntelliJ editor I use does that. And it helps. I misspell. To be honest, I also just misspell stuff all the time. And then I run my code and I see the error. But it's definitely nice to catch it up front. And honestly, a spell check plugin sounds great. We're going to give our student a first name. We're going to give him a last name. We're going to give him a birth date. And this is where, again, leaning into like the power of models can be really good. And I'm not super familiar with date field, so I want to check it out. Represented in Python by a datetime instance. Lot of options here that I honestly don't need to worry about right now. And in fact, I think finding the official documentation is better. Yeah, so I've got this here now if I need it. This is kind of cool, this date field auto now. It automatically sets the field every time the object is saved. We don't need that now, but that's kind of a nice thing to see. It's a lot of options. You know, if I was doing this for real, I'd want to make sure I knew what date format stuff was getting saved in the database. And then we get to the interesting part. The student needs a locker. And here, instead of the foreign key approach, we can do what's called a one-to-one field. And we can give it a bunch of different options. And let's check out the docs for this one-to-one field method real quick. Let's see if it's in here, in fact. Yep, it's right here. And this is great. This tells us exactly what it's doing. It's a one-to-one relationship. It tells us basically, hey, we're using a foreign key with unique set to true. But in this case, it includes some information about the other side of the relationship, and it will return a single object. And then let's see if they give some other methods. They talk about some options. We see that we can set on delete as well. We have this related name, which I believe is just a little bit of syntactic sugar that we can use to point to what our table in question is pointing to. And they have some other interesting things here, like parent link. which is not so critical. And then they do link here to this example of like building one-to-one relationships.
So I did have a question about that. Where it says that the reverse side essentially returns one object,
Mhm.
does that just mean like if you were to call like locker.student, because they could each have their own attributes, which would have multiple, you know, properties and all that. So it just means if you call, like if student were to call locker, they'd get one student. And if locker were to call student, they'd get one locker, or you know what I'm saying, right?
Yeah, exactly. And I think the key difference here is like, we might just, if we didn't use one-to-one field, we would probably get like a list back with just one thing in it. But in this case, because we've gone that extra step of telling Django, like, hey, this is a one-to-one relationship. Django knows there's never going to be more than one thing I need to get. So I can just give you back the object itself rather than like a list with only one thing. And yeah, you're totally correct. Like if I do, you know, my student equals student objects get one. Let me make sure I have that syntax right. Yeah. And then I do locker equals, and then I do, let's see, print my student locker. I believe this will either, this might, excuse me, this is where I wish I did have this shell set up. This might give us the locker itself. I'm pretty sure about that. Not 100%, but pretty sure. And here we might want to tell it what to do on delete. Pretty sure if we delete the locker, we don't want to delete the student. So maybe set null is appropriate here. And I believe we can also give it a little more information, like if this is allowed to be null or not. And let me confirm that. Not sure where it is in the docs, but I am pretty certain we can do this. And this means that when we create a new student, they don't have to be assigned the locker. I think there's also yeah, and we can also do the same thing with blank. which is great because it means because null is an actual value, I believe, in Postgres and SQL. So essentially, we've just made our locker optional. So this is nice. We have a one-to-one relationship between the student and the locker. We have a professor. We have a course. And at this point, we might want to start being able to have the students join the course. So let's take a look at that and how we could do that. And let me check in any questions or things that folks would like me to touch on. Okay. Awesome. So we've got this foreign key relationship, this one-to-many relationship between the professor and the course. Now let's give the course some students. Oh, I do apologize. I had this backwards. We do have to go ahead and create a join table. Django RM does not do that for us. So just file away that thought with the class and let's create our join table. And just real quick, can someone just kind of maybe refresh us on like what a join table is? So a join table is when we have a many-to-many relationship. And in order to store that information, we need a new table. And we covered this, and I know that you folks are familiar with this and that it's the afternoon. To jump over to my little visualization here. You know, a join table would look something like this. Where this would say, hey, the student with student ID is taking course number 3. And so we've got to go ahead and we do have to create that part manually. And let's go ahead and do that now. And we'll call this an enrollment.
Hey, Adam, before you do that, would you mind showing your code again that establishes the one-to-one? So I see you got the unique equals true, but don't you have to set that equal to, for line 33, don't you have to set that equal to the student's primary key as well?
Oh,
Or like, don't you have to tie it to the student or no?
oh, we do that in the student table.
Okay, so you don't have to do it on the other. Oh, because Django automatically makes it for you?
The primary key for locker.
Oh. Okay. I guess for some reason I thought like locker would have a student attribute or something.
Got it. Got it. Yeah, it would be interesting to see exactly what the ORM does. I do have this squiggle here, which I find a bit concerning, to be honest, in terms of correctness. But in terms of the behavior, yeah, like when we create the locker, it's going to have a primary key because we're using Django ORM to do that. And then when we use this one-to-one field method that comes with Django ORM, it will by default use the primary key of the thing we want to relate to, if that makes sense.
Yeah, it does. I just
sure.
thought that locker would have one too, but yeah, you're good. Thank you so much.
For sure. Yeah. And I believe what happens, by the way, is I do think that like I think that what one-to-one field does for us is I think it does let us do, let's see here. Let me look at something very quickly. Yeah. So there's also an argument that we can pass called related name. And if we don't pass this argument, Django uses a name by default. But what that lets us do is like if we wanted to get student of a locker, you know, just making something up here. Student we can do that. And I think, is that what you were asking about?
Yeah,
Yeah, yeah, totally. I'm 99% certain that Django ORM gives us that for free, and that we don't have to add that here in our definition of the model, because Django ORM does some work when we use this one-to-one field method. And it does some work even when we do the foreign key method as well. And that's what this related name courses is here. And I believe, again, it's the same thing where we could do like professor.courses, and it would give us a list of all the courses that the professor was doing. Yeah, that's a really good question. And that's one of the big pluses of Django ORM. Will create those two-way associations for us, which we can name with the, let me make sure I get this right, related name. Yeah, that's a really good point, Alicia. And just to recap, we've got one. Let's do ORM association methods. And we have models.foreign key. And one moment, I just need a sip of water. And I want to make sure, oh, that needs to be a capital F, models one-to-one field. Got one-to-one field, which is used for the less common and pretty obviously for one-to-one relationships. And then we've got models many-to-many. Let me make sure I have that name correct. Many-to-many field. Right. We must also create the model, which will be join table manually. Yeah, and the great thing is like once you get into this system and you're using Django ORM to do this, it just does more and more and more for you. And I want to finish building our enrollment so that we can see this many-to-many relationship. But yeah, Alicia, that's an excellent point about that Django ORM is giving us that two-way connection without always having to modify like the other model in question. Excuse me. Does that make sense?
Yes, thank you.
For sure. Thank you. Yeah, and let's put together this enrollment and check it out. So this is our join table. Table for the many-to-many relationship between students and courses. So we got to have a student. And essentially, we're creating a bunch of one-to-many relationships here. And here, if a student drops out, it definitely makes sense to me that we want to get rid of their enrollments. Though truthfully, even in a real world situation, you might not want to. In fact, you probably wouldn't for historical reasons. So you know what a student was previously enrolled in. There's a lot of times where you want to save a lot more data than you might realize. Or maybe that information is stored somewhere, or maybe you do a batch job to save that information somewhere else. It can end up getting kind of complex. It's not a trivial, all these things like end up being more complex than you think. But for our purposes, we can just say, hey, we live in the present. The student is gone and we get rid of the enrollments and we have like that historical information somewhere else. And it's complaining because the student is defined over here. I see. Let's bring our student up here. Let's bring everyone up here. I think that'll make it a little clearer. And then I'll move this sort of example code to a better file later too. And that took care of that issue, which is great. And again, Django does a related name by default, but and in fact, we can see what that is because I did see it was referenced somewhere in here. Yeah, and the way they describe this is great. The name to use for the related object back to this one. I guess in certain cases, you do have to set it. They talk about abstract models. I'm not sure what that is. I did see somewhere that Django uses, this is interesting. If you don't want a backward relation, set related name to plus, which honestly is like one of the worst. Well, I don't want to prejudge why the Django folks made that decision, but it's certainly not intuitive. I'll say that. And it's something that we don't need to worry about because I think we're always going to want those backwards relations. That's like a very special case. So there's a default somewhere for what related name is, but with a lot of the times with complex frameworks like Django, it's just easier to do it manually. And then we can look in the code and see what it is without having to refer to documentation or anything like that. And here I'm creating another foreign key relation because this is our join table like we have over here. We have student ID and course ID, and that's what we're creating right here with these two fields. And let's think about this. So here's an interesting question. What if a course gets deleted that has enrolled students? What do we want to do? Do we want this cascade operation where everything gets deleted? Was someone saying something? Okay, my gut says we don't want to just delete everything. I think set null is a great go-to. So let's do set null, and let's make notes here. If the student is deleted, their enrollments are also deleted. If the course is deleted, the enrollment is kept with course set to null. And honestly, I'm not sure that's any better. Neither of these are ideal. Like, we don't want a bunch of enrollments with students with no courses. In the real world, this is a bit of an interesting case because we have to notify the students, right? So we might need code. It might be in the model. It would probably be above the model before like the delete gets called. So in fact, maybe instead of set null, we want protect. A course cannot be deleted if students are enrolled. And this is a little in the weeds for like the kind of things that we will be doing in class. However, it is very useful to start thinking about things this way to prepare for being on the job, because it's very common. And during technical interviews, you're not going to see a programming problem where they ask you about this. But if in a technical conversation, you have a chance to be able to talk about things at this level, I think that would be very impressive. So now we have enrollments and we've got students, we've got courses, and we've got a grade. The students are going to get a grade in the class. And we're going to use a validator, and it's going to be awesome. And we're going to do a regex validator. I am terrible with regex. This is not, I'm bringing this from our curriculum doc. I can kind of read this regex, but not a ton. And don't worry about regex. I really think it's like when you need to, you learn what you need, or you find a Stack Overflow post, and then you move on. That said, if you enjoy regex, and some people definitely do, then more power to you, because it's a very powerful thing. And I probably have something not correct here, so let me figure out what that is and fix it.
Should it be validators equals?
Thank you. It totally should be. I can't see faces, but I think that was Rexford. Thank you. So that solved that. And I need to import the regex validator. So let's let's see, what do we need to, what's our file name here? From validators, from Django for validators, import regex. And so as you folks saw, I did import star earlier this morning. if you haven't seen it, star stands for everything. I think it in fact is from regex. And so doing this would import all the validators from Django core validators. That's not a great habit. Sometimes it's totally fine to do it. The reason is, imagine this wasn't the Django code. Imagine this was like my code. And imagine we're in a big code base and I need to move this file, or I need to change one of my validators and I need to see everywhere else it's used. Our editor can do a lot of smart stuff for us, including seeing like where things are imported and used. And we lose that information if we just import everything. So that's a bit of a digression onto kind of more like just good habits for managing larger code bases. But I just wanted to mention that and also touch on what that import star was. And now we should be happy and that should be working. And I think we have everything we need for our enrollments. So there is one more thing we need. And this is saying essentially, hey, like, we only want unique combinations of students and courses. Like, I don't want the student to be able to enroll in the same course twice, because that would mess up our system. Like, we'd be doing queries and we wouldn't be able to tell what's what. That's not something you want. And it's like, you'll hear the term composite primary key. And let's look a bit at that class model meta and see what's going on there. So essentially, it lets us do a lot of different things. Like if we wanted to, we could even specify the name of the database table for our model if we didn't want Django's ORM to just kind of decide those things. But what we care about right now is understanding this unique together method. And it looks like there's an update on a better way to do this. That's what this little note here means. To be honest, when you see something like this, don't worry about applying it right away. You can come back to it later. And in fact, that's exactly what I'm going to do. I'm going to leave a little to-do note. To-do, use unique together, use unique constraint. And a note to where that thing is, and then I'm not going to worry about it. And I'm going to come back to it later. And pretty straightforward, this tells us we can pass it a set of field names or columns in our table that together must form something unique. And you will hear the term composite primary key used to refer to these. It's still good to have a primary key most of the time, but it's just good to know. And then there's some other rules that we don't really care about here, but that's the basic idea. Does that make sense to folks? And do folks have any questions about this unique together, this meta nested class? That's a bit of a new thing for me. I don't see a lot of classes defined inside other classes, but Django has its reason, and meta, is referring, it's not quite metadata, but it's, information sort of about the nature of the model, the meta information about the model, like what database table does it use and things like that. And it looks like they have kind of crammed a whole bunch of different things in there. It's like that drawer in the kitchen, that like the box cutter and the tape measure and like my wallet and like the rubber bands live in. Yeah, Daniel, yes, sir.
Yeah, what would that look like? So I can kind of envision, querying for certain information using like a one-to-many or a one-to-one relationship, but like, how do you, what is utilizing the meta class look like?
Yeah, totally. Let's finish this off. And I
Sure.
think that will demonstrate really nicely um, what you're asking about. And let me
So
go
is that,
ahead.
is that also saying like you can't have a repeat of a student course combination? So like, student Jack in course science wouldn't show up twice in the table. Does that also do that or not?
Yeah, that is exactly what it's saying. Like, I don't know if this is what you're asking, Daniel, but this is what that meta unique together prevents. Like, the second time we try to do this, we will get an error, and it will be impossible using Django ORM to add that in. It will not let us put in a duplicate. Yeah, that's a good question, Alicia, for sure. And jumping back over here, so we're jumping over a bit. Do folks mind if I close the Explorer for the moment, just because we're not moving between files a lot? Okay, I'm going for it. So I had this commented out, and now we're bringing it back. And again, the issue here actually is the student model needs to go. I need to do a little reordering.
Oh my gosh, when we were making all those databases, I didn't realize, of course, that anything that referenced another table would have to go first. And I had to delete and recreate tables like 100 times.
Yeah. Oh man. Yeah. Yeah. Totally. Totally. Yeah, I think I have this in the right order now. I'm not seeing any squigglies. I think we're good. And then this uses our enrollments joint table to form a many-to-many relationship between students and courses, i.e., one student can be in many courses and one course can have many students. And I just wanted to get to this point, Dan, because I thought that it might help illustrate the question that you were asking. And I'm not sure if it does, so I just want to check in.
Yeah, so that makes sense, right? So you wouldn't want in your enrollments, right? You wouldn't want to see like a duplicate, like I guess if the enrollments, if we're looking at like current enrollments, right? Like you wouldn't want to see the same student enrolled in the same course twice, which I mean, that makes sense.
Exactly. Yeah. And that's what this unique together does. And the reason that like we worry so much about those kinds of duplicates is because like in this case, enrollment also has a grade, So like if we have sorry. I like your idea, Alicia, of just using names for this example. Jack, let's just do biology because that's the one I have up there. Grade B. A. We have two of these. We have no way of knowing which one is the correct grade. And it gets even worse if it's like, what if we need to do a query to get all the students in the biology course and we get two Jacks? And
well, that's easy. You just ask Jack what he got.
Yes, that's an excellent point. I actually,
Salt.
they should have a method for that in the Django model. In the ORM method. Yeah, I like that approach. And Jack will say, which one did Jack get? The A or the B? He got the A, of
I mean,
course.
that's obvious, yeah.
Yeah, sorry, I shouldn't ask silly questions like that. Yeah, no, that's a great point. I mean, and kind of to that point, you folks will be surprised once you kind of start getting out there and working, like how messy real world data is. Like it's all a huge mess. I think is the simplest way to put it. It's all a big mess. But here inside the world of our class, we can have everything be nice and organized and clean. And Django even calls it like clean, like keeping stuff clean. And just to show, I think the last thing we really need to touch on, because I think we're in a pretty good spot, is I just want to create a custom validator and import it from another file. So let me create a validators py.py file.
Hey, Adam, actually,
Yeah.
before we move on,
Oh yeah, because it is
From,
245.
before we move on from talking about associations and stuff like that, I'm just kind of curious to know what that unique constraint looks like in the database.
That's a
Could
great
you
question.
run the migrations and then just use pSQL to look at that table?
Yeah, let's do that. That's a great call. And
I'll take a minute.
I will admit, I have been a little afraid to run my migrations because I've been worried that I've got something wrong. Actually, Raphael, I could use some quick advice on, we have some sample code of interacting with our models. What would be a good place to put that? Just stick it in views.py for now. I don't want that in the models. I'm guessing we don't want that in the models directory.
Yeah, views is a little bit closer to where it'll be.
Yeah, thank you. Related to that, I was trying to figure out with the Django shell, can you import, can you like enter the shell on the command line and then interact with models and do things like that?
You should be able to, yeah.
Okay, I wasn't sure how to get that working. And actually, once we run our migrations, it would be great to maybe get a little help with that. But let me import course, professor, student, locker. Okay, and this, by the way, folks, is just a great example of what I was mentioning earlier. Like we could do this to import everything. But the challenge here then is as our code base gets bigger, it's harder to tell, like if I need to see everywhere that we're like interacting with the professor model to make a change, this makes life difficult. Awesome, so we've got that here. The programmer in me is like, we have to save this to Git, even though running a migration isn't going to mess with anything. So I just want to do that quickly. We've got Twitter apps, we've got school, we've got notes. Cat is a command line tool that just prints stuff out. So let's move. I will organize it all later is what we will do. Week 7, day 4, Django associations. Okay, awesome. And now if I do something silly, somehow I don't have to worry about it. And that's kind of my goal in life with programming. So now we've got to go ahead and make our migration and run it. Let's see. Yeah, so Python. Python manage.py. Is it make migration? It is. Make migration school app. Let's see, can't open file manage.py. Where am I? Let's try that again. We have created our migrations. They've given us this beautiful message. And let's see what the SQL is going to look like, just out of curiosity. And that should be the very first migration. No, I guess we actually have two because I ran one before. So that creates, the first migration creates the professor, creates the course. Second migration is going to add all of our relationships, create students and enrollments. And let's migrate it. So we have applied all the migrations. And yeah, Raphael, I really like your idea of popping in the database and seeing what's going on. And let's look at the different databases with /L. Week 6, day 3, school, no, the school 2 database is our database. So let's connect to that. And let's look at it and make sure it looks right. And we see all sorts of interesting things. We've got school app course, school app enrollments. Basically, we know we're in the right database. And Raphael, remind me what we wanted to look at in here again.
So I wanted to see that unique constraint that you made, unique constraint on 2 columns. I just want to know what that looks like from the database's perspective, because we saw how it looks on the Django side.
That's a great call. That's a great call to look at that here. So that would be on the enrollment. So I believe /D and then the name of the table will give us information about that table. So let's give that a shot. And let me temporarily close our Explorer window, which actually makes this much nicer. Yeah, and so we're looking at the school app enrollment table. We've got the ID column. And that's what Django ORM built for us. It's the primary key, the grade, and we're gonna maybe add some validation for the grading. And then our foreign keys, course ID, student ID. So we haven't talked a lot about indexes. Indexes are just indexes, like lists that the database puts together using a tree, I think, to access stuff more quickly, and it creates it automatically and we don't have to worry about messing with them. And then it is, let's see, foreign key constraints. So this is interesting. Oh, there is the unique constraint. It's under indexes, in fact.
Yeah,
So
that's
it looks like that's how it implements it.
I just think it's interesting to know that that's what it looks like. A lot of people treat these ORMs as like magic, but it's really just like a program that writes SQL commands for you.
Yeah.
So I don't want you to treat it like magic. I want you to understand the SQL that the ORM is helping you write. So it's important that you're able to recognize this. Like if you try building your own database and you want to have a unique constraint on enrollments, something similar to this, and it's not working the way you expect, you can look in your database with pSQL and make sure that it looks like this. And if it doesn't look like this, then you can know that you've probably set something up incorrectly in the ORM side. But I just think that we should understand the connection between the two.
Yeah, that you're totally right. And thank you so much for suggesting that, because it is great to see and look at.
Yeah, in particular, you can see in the unique constraint in parentheses, it says both of the columns there. Student ID and course ID. If it was just like the grade has to be unique, it would just say one thing in the parentheses.
Yep. Yep, totally. And the ORM does the nice job of, like, we don't tell the ORM what columns to apply the unique constraint on. We just tell it what models, and then it tells the SQL, all right, these are the primary keys.
Yep, Django's pretty smart.
It's pretty great. And actually, in that same vein, can you walk me through how we would use the Django shell to run it and then interact with our models so we could actually like add data and do queries and things? And if not, that's okay. That's a tangent question.
Yeah, just give me like 5 seconds here. I'm just
Yeah.
getting up from the.
No rush. I thought I knew and I didn't have it.
While he does that, I'll sneak in another question here.
Yeah, absolutely.
So I wanted to ask, like, I keep thinking of these models as like Python, models, because they are, but then I had to remember these are like kind of like specifically to create tables in the database. And so then I find myself wondering, are there any major differences between the two that, like, like you can't have a function as a method, for example, or anything like that we would kind of need to know is a limitation of these Django Python models versus a regular one. And then along the same lines, can you in fact do something like, and would it be self, I guess, or maybe you just reference the variable name, I guess, like, like GPA average. So under student, you could have GPA, and then you could have a function that essentially takes all of their grades from all of their classes and adds them and averages them.
Yeah, that is a great question. Let me tackle the second question first. I am not 100% with Django. With Ruby and Ruby on Rails and its version of the ORM and models, I have definitely seen things like this. And then I'm going to steal a little bit of the code that we wrote. Where is it living? In the views. Let's see, I think really that's what we need. Let's see here. Right, courses. It does, let's see, it gets a little tricky here because we need to do something like self versus, how would we do it? It would probably be something like, let's do student. This student objects. I need to look into the syntax. Actually, I'm not going to try and write the code out. Instead, I'm going to pseudocode it. Get list of all courses for self using sorry, get list of all enrollments for self. Then we would sum up grades and average to get GPA. So I have definitely seen that done in Ruby on Rails in like a model file. There are other ways to do it. Like you could maybe have code living somewhere else, sort of a level up that uses the model. And that probably depends on taste, and Raphael would kind of know the Django conventions better. when you were, the first part of your question, when you were saying like normal models, do you mean like using a model in Django that's not part of the ORM and like talking to a database and stuff?
No, I guess I thought that Django did talk to a database through ORM models, so
Yep.
maybe I'm missing some insight there.
No,
But
you're right about that.
Okay, but I just meant like a regular Python model that could have functions as methods, and do you have the same flexibility of also passing in other functions and stuff like that?
Gotcha. I am not, are we talking about a
And you're
class?
probably not looking at the chat, but just so you're aware, whether you want to look at whether you want to do it or not, there's a few people asking for a break.
Oh, yeah, we should totally do a break. That's a great call. If you mean, do you mean a normal like Python class? I'm not sure what.
Yeah.
Yeah, got it. Okay, the word model threw me off. Yeah, so it is totally a normal class, and this is very common with frameworks. Like, we can do all the things we can with a normal class. We just need to make sure that we don't do anything with it that Django won't like, essentially. Which does mean we can do lots of stuff, but we kind of want to follow examples and documentation and tutorials, and honestly, if it works, then it works. There's a bit more to that than that, but it totally is a normal class. And at the same time, like, Django does use models in a special way. So we just kind of have to be aware of that. I can't think of anything off the top of my head, like, not to do. Like, it's more like the fact that there's this behavior, we can create this class meta inside this other class, and that it just, like, Django knows that it's there and it'll do stuff with it. Like, that's pretty weird, but that's pretty common for these kinds of frameworks. So it means maybe there are certain like method names that might conflict with Django, but I would kind of say go for it. I think the rule of thumb with these models is we just want to make sure that whatever we do, we're keeping it relatively simple to understand. And if you find your model starting to get big and complex, then it might be time to pause and think about, should I move some of this code elsewhere? And that's not an easy thing to answer. Like, you would probably be talking with other people on your team about that. And so in this situation, that's definitely something good when you run into a specific situation, to reach out to a TA or Zainab or myself. Did that make sense?
Yes, thanks.
For sure. Yeah.
I
And
would
there's
love
no,
to eventually see that GPA thing, because that I think would help to know how to kind of tie it all in, but not right now. It's fine.
yeah, totally. I think that's going to be the first thing we do after the break. I think we should totally take a break. Thank you, Alicia, and thank you the folks in chat for saying that, because I forgot about the break, and that's critical. Let's do what do folks want to do? 10 minutes, 15 minutes? Let's do 15 minutes. Come back at 4:15 because it's already 4:03. So I guess it's a 12-minute break. Come back at 4:15. And then we will build this get GPA function. Cool. Thank you, folks. Go ahead and resume. I'm going to go ahead and resume recording. And Rexford, thank you. And Raphael, thank you for showing me how to properly use the Django shell for what I wanted to do. So I was half right. And now it really hates me for some reason. Let me make sure I'm in a decent directory. I am. So now we better look at the error message.
It looks like there's an error in your models.py file. It might be preventing it from letting you access the shell.
Yeah, thank you. Yeah, and it took me a minute to get there, line 29. Yeah, in the course class. And in fact, I have this squiggly expected indented block, unindent, not placed. Okay, so let's just
Pass under, oh, never mind. Do you
Yeah, it's
have
because you
different
haven't
paths under
finished
GPA?
defining. Yeah, you didn't finish defining your GPA function.
Oh, thank you. Yeah. Yeah, let's do that. Awesome. And that is what we're gonna do next. I don't think it'll take too long. I want to do it using the shell, both to show you folks how awesome the shell is and because it's the best way to kind of figure out, I think, the right way to do stuff. Awesome. And now we are in the shell. Beautiful. And so the piece that I missed, I was like halfway there, that I got some help with was we're in the shell, we're in Django, but just like if this was a file, we need to import stuff. And I just didn't know the right path. And the path is, I believe, let's see, it's going to be school or school app. Let's try school models import students. No module named school models. Yeah, so it might be school underscore app. Let's see if that does it. Beautiful. So now I've got the student model. Let's go ahead and just import everything. I said not to do this with the star, but this is a great time example of when to break the rules because now I have professor, I have a locker, I have everything. Let's go ahead and create some data. So course, let's see. Now, of course, here's the issue where I am not as familiar with the Django models as I want to be. Django shell models. So you guys can't see me, but I'm just doing a quick Google. Course objects get. Course matching query does not exist.
I think you import.
Sorry?
I think you need to import first. You have to import the courses from the models.py.
That one I did.
Oh, okay.
The import of everything. I think the issue may be that there's simply no data in the database. Let's see if this works. Let's try creating a new course. And we can put this stuff in action. It needs a name. It needs a professor. And in fact, it might even require, no, I think the enrollment, we'll see how this works, but we're gonna have to start by creating a professor. P equals professor. That professor needs a name, Xavier. And let's bring this over here. First name, last name. So first name is, of course, Charles. Last name is Xavier. Let's see if this works. Beautiful. And P, and now we have information about our professor. First name, last name. We can even do P. I believe it was full clean. Was that our correct command to do all the Django validations? It is indeed. We don't have a lot of validation on the professor, so that's fine. And now we can do p.save. And now if I pop over here to my SQL and I do select star from professor, let's see here. Relation professor does not exist. Where are we? School app professor. So this is the challenge of jumping to the SQL, the names are a little bit different, but I've got my professor in the database, which is awesome. So we only need one professor. We do need a couple courses. So let's create a course. And the name is going to be biology. And I believe we're going to have to also, if we look at our model, this is where it'll get interesting. I'm pretty sure this will fail. I think it requires a professor. I was wrong. Okay, so let's try C dot professor. Course has no professor. C equals course name biology. And this is where this may end up taking a little longer than I thought. I may have to shift gears, to be honest. But if I can, I want to walk us through this. We are expecting a foreign key for the professor, so let's see how we do this. P.id. A professor ID is of course 1. Course name biology. Professor equals P. Let's see if that works. Yeah, that does work. So this is the beauty of an ORM. And let me just kind of walk through what I just did here in the console. Kind of going from the top. And I'll do it again, in fact, with a new professor and a new course. I'm just using a variable. I'll just use prof for shorthand for a new professor. And a professor needs a first name. What's Magneto's name, by the way? Like his real name?
Isn't it like Eric?
Sorry?
Eric?
Oh, it is, isn't it? Eric, what's his last name? We're going to go with Ian McKellen, the actor who plays Magneto, because I know his first and last name. But thank you. Although I do see something in the chat. Eric Lent. Oh, all right. Beautiful. Thank you, folks. Let's do it. It's too bad we don't have a nickname field for these professors. And sure. All right. So what I did, I'm creating a professor. And because it's a model, we can run this full clean method. There's not really any validation that happens with the professor, but it's a good habit to get into. And now if I do prof.save, that saves the professor to the database. And we can see that here, we now have 2 professors. Now, if I want to create a new course, I'm just going to use C for course. I don't want to use the word course because I don't want to get it confused with the class name. The course needs a name. This one will be physics. And a course needs a professor. If we look at our models table, the professors here, we could have, but we didn't in this foreign key relation add like null equals true or blank equals true. I think that would look something like this. Capital T, which I always forget. Which would let us create a course without a professor. But we didn't do that. And if we wanted to, we could create a new migration to make that change, but we're not going to worry about that right now. So we need to add a professor. But because I'm using Django ORM, and I'm working at the level of models, I can pass around the model objects and Django ORM understands those relations. So this prof variable, sorry, I was pointing to it, which you folks can't see, but this prof variable, which we created, that's Professor Magneto, Eric, whose name in the X-Men world is Eric Lenscher. And I think just to recap, X-Men are a comic, right? I'm pretty sure everyone knows X-Men, but it's good not to make assumptions. Bunch of movies, and Magneto's sort of the villain, anti-hero, and Xavier's sort of the hero. And so that's where those names come from comic books. But Professor Lenscher is just an instance of a model class, of our professor class. And we can pass that in here because Django ORM is making these connections for us. And we have this course, which actually I'm going to rename physics course, because that's a bit easier to read. And now we've got a physics course. It has a professor. Oh, right, not named that professor. We could have and should have added string methods to all of our models, and then everything would print out really nicely. But we can go ahead and just do this. And I think, interesting.
Should be first name.
Oh, thank you. Thank you. Awesome. I always forget that. And Django ORM, though, has connected this information for us and lets us work at a higher level of abstraction than with the SQL. And we should go ahead and save this physics course to the database because we haven't done that yet. So if I quit this Django console, the physics course will go away. So let's run full clean, see if any validation gets triggered. Everything passes, which is great. Hit save. And let's go look in our database. I need the semicolon. And we've got physics. And I guess I didn't add the biology course. So I'm just going to do that very quickly, just to walk through this process one more time. And I'm just going to do, so I want Professor Xavier to teach the biology course. So I need to get him. And the great thing is you have your history here, just like in the normal shell. So let's get Professor Xavier. Professor objects, get. I think we can do this. And that works. I'm curious how good this is. Can we do name, first name? And we can. So there's a lot of different ways we can query here. It doesn't just have to be by primary key, which is great. And let's create a biology course. And Charles Xavier, Professor X, is going to teach it. And let me confirm that I'm seeing what I expect to see. Voila. Oh, Evan, thank you for that extra level of information about Magneto's birth name. That's awesome. We have 2 courses. We have 2 professors. We now need to create a couple students. So let's make a student named Jean. Let me look at the student model. Let me check in and see if folks have any questions too while I'm doing this. And this is going to be annoying because I'm going to have to remember how to like create a proper date to pass in for our date of birth. But let's try it. Let's give it a shot and do it. And let's see here, birthday. Let's see how good that date field is. I'm just gonna make up a date here. I apologize to any people who really know their X-Men for making up the birth dates. 2/2/1973. I don't think this is gonna work, but I'm curious. And it did, actually. So I figured I had decent odds. This date field is pretty smart. It will accept a string in some kind of standard date format. I suppose the next question is if it saves properly to the database. And we do get an error here when we run full clean. And in fact, this is our birth date validation method. I love it. And I'm sure if we went and looked at the docs on date field, it would say that it's a char field that uses a regex because that's exactly what the email field does. The great thing about this error message is it tells us the format that it needs to be in: year, month, day. A good example of why taking the time to write good error messages is so good. So
did you write that, Adam, yourself, that one?
That date?
That
this
error message?
No, I did not. That was
That came with the date one, right?
yeah, that was Django. We just got that for free with this date field model field. Yeah. So, and what's happening here, and this is the same way the email field works, is under the hood, I'm 99% certain date field is a char field with a validator. And the validator is probably a regex. If not, it's a bunch of logic that looks at a string and says this string has to match a date format. And that's how they're doing that. And it's kind of cool to see like the pieces get put together. Like we totally could have built that, but Django does do that for us. And for dates, it's great to use it. If we maybe in a real application, we would want like to write our own field for birth dates if we wanted to store it differently or something. But the Django built-in one is great. So let's try this again. 1973-02-02 birth date, Gene full clean. And now that validates successfully without an error. And now we can save Gene. And now if I do select, let's see, it's school app _ student. We've got Jean Gray in there. And now let's try to enroll Jean Gray in a biology class and a physics class. And this is where it will get interesting, I think, and where I may hit the limits of my knowledge of doing this stuff in the shell, or just with Django. And just to review, looking at this, an enrollment requires a student, it requires a course, and it requires a grade, I believe, unless this regex allows for like an empty string. We did not allow a grade to not exist, which is something that is obviously an oversight for a real data model. And, in a real situation, we would update this model and build a new migration. But for our purposes, we can just come up with the grade. And this also raises a question because Alicia, you asked about calculating GPA, and I didn't think about it at the time, but we only allowed letter grades in here and like A- and or B+ or whatever. So we can still calculate a GPA, but we have to do some translation. And to be honest, we might have to hold on that. I think what I want to do is create the enrollments with some basic grades. I think that I would like to show just writing an external validator and importing it. And then if we can, I do want to get to that get GPA method. But how are people doing with this so far? Are people feeling good? And is this useful? And Alicia, yes.
Yeah, so Dawn had a question a while back that now that we are continuing along this same process, I wanted to just ask it out loud. Because I actually thought when you made an entry, you'd have to do that in migrations, and maybe I'm just forgetting from last Friday. But you're doing stuff in the shell, and then I thought that was just going to be all temporary data, but it looks like you're actually adding it into the database through your shell, which I didn't know that you could or would do that. So can you just speak to that real quick?
Yeah, absolutely. That's a really, really good point. You are totally correct. We are adding database in through the shell, which is kind of amazing and kind of magical. It also, again, just illustrates that none of this stuff, when you break it down, is magic. Like, we're writing code exactly like we would in a file. I have to call save to save it to the database. And we could do all this in a file. All that the shell is doing is whenever I hit enter, it just the same way you could imagine, it's basically like creating a little Python file and then executing it every time I hit enter. That's not actually how it works, but the point being that we're using all the same pieces. And because of that, we've got all the power of Django with us, every single thing, HTTP requests, Psycho PG2, the Aura models, and so on. And so because of that, we can use this save method, and we have our connection to Postgres because this is the Django shell. When it starts up, it does a bit of work for us, and we can save that stuff. Does that make sense just on a level of sort of like why this works?
Yeah, on like a surface level, yeah, of course. But so is this kind of the recommended way, like as we continue moving forward with our homework and creating our database and making users and all of that, is this the recommended way?
Right, that's a great question. And you were asking that as well, for sure. Yeah, what the shell is good for is experimenting, prototyping, and developing and experimenting and prototyping as you develop. Like for a real world application, we would normally not enter user data through the shell. Though the truth is, at companies I have worked at in the past, sometimes if something gets really screwed up with a particular user account, you might just pop in the shell and modify it and fix it that way. I've definitely done that. And then you ask a really good question too about migrations and putting user data in there. Typically with migrations, in terms of entering data into the database, as opposed to creating our schema, like creating tables and relations and modification and things like that. If we're putting data in a migration, usually that's for the purposes of creating what's called seed data or test data. Like, again, if this was like a production, a real application, like we would probably have a migration that creates a whole bunch of imaginary users. And truth be told, that might not even be a migration. We just might have a script that gets run at some point to create a bunch of imaginary users. In fact, it probably would be that, because the migrations, so here's the value of migrations. Like when you need to build your database, like on a new server for a real world environment, or something has gone wrong and you need to like rebuild the database, or anything like that, your migration files, just like with Git and the code, are kind of the source of truth of how to build that database. And so for migration files, we wouldn't want like non-production information in there. So we probably wouldn't put like imaginary test data in migration files. For our purposes, for learning and for building projects, it's more than okay to put stuff in migration files. We haven't gotten into it, but you can delete migrations. And so like as a developer, I've definitely like created migrations and then just to get going and then deleted them later. Like, and there are processes to do that safely. In terms of us for this course, either method is fine, I would say. I think the nice thing about the shell is it lets you kind of poke at stuff interactively. Did that make sense? I know that was a bit of a big response, and I want to make sure that I gave like a good answer to your
No, that was
question.
a great answer. Thank you.
Yeah, for sure. Yeah, that's a great question, especially as we're looking at these different like approaches too. There's just a lot of different ways to do things, and there's a lot of like contextual knowledge about like how do you use migrations for like a real application and stuff. The console is super powerful, and I use it all the time when I worked on similar projects with Ruby on Rails to debug, to prototype, to fix problems in the database that were like small individual user problems. You know, what you don't want to do in like a real world application is use the console to like modify the schema, right? That definitely should occur in a migration. I'm not even sure if you could do that in the console, but if you could, you shouldn't. Yeah, great question. Great question. And we already saved Gene. I'm curious if saving it multiple times creates multiple Gene grays, and it doesn't, which is great and what we expect. Yeah, any other questions? What else is on folks' mind? Because it is almost 5 too, so we may have to call it in a few. Okay, let's just look at 1 or 2 more things and take it on home. I think what I want to do is just very quickly show creating. Let's see, we're so close here with this. Let's see if we can't get an enrollment or 2 in, actually. Let's do that, and then we'll look at an external validator. So for an enrollment, we've got a student, we've got a course, we've got a grade. So we've got our student here. We need a course. I want biology. Let's see if that course is still around. It's still there, which is great. So let's try creating an enrollment. Bio enrollment equals enrollment. Student equals Gene. Course equals biology. Grade equals A. And that works. Let's see if it passes validation though. It does. Let's go ahead and save it. And I'm going to do that real quickly for physics too. And if we didn't, I think like we already have physics. We don't. Physics equals course. Objects get name equals physics. And that confirms that I have what I expect. And again, we can just do phys enrollment equals student, Gene, course, physics, grade, also A, which will make for a very boring GPA calculation, but that's okay. Awesome. So here's the cool part. Let's prototype our GPA calculation. We've got our student, Gene. Let's see. what they call it in models. Enrollments is the related name. So let's see what happens with gene enrollments. So this is a long something, 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 something. I don't know if it's a list. It's not, maybe reverse many to one related manager object. At this point, I have to do a quick Google. I would like to find the Django docs on this, but if not, there's this other site which says it's a reference. It looks like objects.get. See
What are
if
you
that-
looking up right now?
Oh, I am,
Trying to,
yeah, I wanna. Okay, that's how you do it. So gene.enrollments gives us some kind of object called related manager. And that's the list of all the enrollments. And I know how to get a specific enrollment by ID, by name. I guess I don't know by name, actually. That's fine. We can get it by ID, which is all that really counts, to be honest, because I can probably also do .name. Or no, but we have that. What I want to do is I want to be able to iterate through this list. Because that's what we need to do for the GPA. I'm sorry?
you do .all.
That is a great question. .all. We can indeed. That looks great. Yeah, so this is, I'm not going to be able to finish this get GPA method completely, but it would look something like this. For enrollment in self-enrollments all. And let's make num enrollments 0 grade sum equals 0, and we'll fill this in. This is, I'm sure there's a better way to do this arithmetic too, but just num enrollments plus equals 1 and grade sum equal grade equals enrollment grade. All right. And you know, you would fill in the rest.
So that's, I mean, that's really helpful to see all of that, but it actually got me thinking about this other thing is that you keep using, you keep creating instances of these classes, which on the one hand makes sense. But on the other hand, back when we were just using the databases, each row didn't have its own variable name, right? So like Gene would just be a row of data in a table. She wouldn't necessarily be, you know, a variable that you would then. So how often, I guess, are we just always going to instantiate, is that the right word?
Yes, probably.
These instances, and then is it pretty common you just start referring to them by that variable name that you created?
Right. It is super common. Yes. Yes, totally. This is kind of like working a level higher in terms of abstraction with our data. And so it is totally okay for us to just kind of create variables left and right and create instances of model objects. From the perspective of Django and Python, all those model object instances are tiny. Text is tiny in terms of the amount of memory it takes. Numbers are tiny. And because we're using the ORM too, like for certain things, like self-enrollments, all, like we don't know exactly what SQL it does to make this happen. Like it could happen all in one query, and then that result like lives in some sort of list that we can then iterate through here. As we do more and more complex stuff with the ORM, it will make decisions for us about what the most efficient way to interact with the databases in terms of SQL queries. So it can do a little bit of optimizing here and there. But yeah, so, and for that reason too, it generally speaking, it's okay to do stuff like this. You do raise a good point that like when working with larger amounts of data in real databases, it does become important to understand a bit more of kind of what SQL is happening, just to make sure like if a student could have like 10,000 enrollments and this get JPA method was something that was like being executed all the time, you know, then we could run into issues. But if we don't have like those questions of scale, then we're generally fine. Yeah, that's a really good
I
question.
imagine then you start like really running into like variable syntax, like, okay, this is going to be Adam underscore last for a social to separate it from every other Adam under the sun.
In what? Well, a lot of the
It's
times,
food for thought, not a big, we don't have to
got it.
discuss that, but yeah.
Yeah, the nice thing with a lot of this stuff too is like if stuff gets more complex, like, you know, we'll wrap it in a method and then just call that method. And that's kind of how we manage complexity too. Like this get JPA method could even end up living somewhere else potentially. And so then that's a way where it's like the get GPA method doesn't know if it's Adam or Gene or anyone else. So there then are kind of like techniques that we can use to like avoid the sort of, because you do raise a good point about like kind of like name spacing essentially. But I'm tangenting a bit now, so I apologize. And Dalton, yeah, we veered a bit with this get GPA method. Like we didn't really, this wasn't in the curriculum, but I thought that this was useful to see because I really wanted to show how we could use the console to prototype stuff. Like I didn't know how to do all the right Django method calls off the top of my head. And I kind of built it up step by step in here to figure out what I needed. And then I kind of grabbed some of that and brought it back in here. And Alicia, thank you for that .all. That was critical. And now like if we ran a migration, in fact, and reran this shell, we could then use this get GPA method in the console. And I think the console is definitely your friend when it comes to experimenting and building stuff. And just very quickly, because it is 5 o'clock and then we do have stand down, I want to show how to write a validation method, an external validator, and use it in our model, which is pretty similar to what we've seen. I'm going to write a really simple one for locker numbers. And all we're doing, we're really saying, truth be told, I'm not sure why we would do this in the real world. Like what what school has less than 60 lockers, and what school wants to like lock that information, like you don't, adding more lockers is something that could happen very easily. And so we probably don't want to hard code into like our model validator, like the maximum number of lockers. That probably belongs somewhere else at like a level above our validators. But in any case, it's a great example. It's short, it's friendly. So let's go ahead and import that from validators. Import, and now I've already forgotten the name of what I wrote, is lock digit valid. And then just like we've been using our other validators, we would use it right here. And I believe that would look something like this. And I think that would do it. And then the real test is let's run a migration. Not Twitter. And I do have an error. Manage PY. Make migration school app, couldn't import Django. Oh, because I'm not using the Python environment. No module named school app.validator. Oh, so this is my file name is singular. Let's just rename that to be plural. Validators. Let's try this one more time. And we have a new migration that's going to do all sorts of awesome stuff for us. Migration number 3. With some stuff with the lockers. I'm not sure if it's doing a ton else. And then we can run it. Python manage py. And so I do believe this is going to delete all the data in our database. I'm not 100% on this, but often running migrations, I would have to look at the docs, but it's definitely, no, it shouldn't. But let's find out. Do we still have? Okay, it does preserve data. Yeah, that would be really bad if the migration deleted data. Yeah, so that's really everything, folks. It's pretty much time for stand down. Let me go ahead and stop this recording.